Zinga spray. And Zinga spray usually is slow moving as compared to Zinga spray. So, थोड़ा you tell us about your success for Zinga spray.
जिंगालू स्प्रे में इनिशियली में ये था कि
English, let's talk in English so that Rick also understands what the application is, na?
राइट राइट
Yeah.
क्लाइंट को हमने रेकमेंड किया कि ये प्रोडक्ट आप बेटर है, आप इसको यूज करके देखो। फिर हम उसके बाद सैंपलिंग में हमने दिया पेट सैंपल, बींग पेट सैंपल दिया।
हाँ.
पेट सैंपल के बाद उनका इश्यूज था कि कितना कवरेज आएगा, क्या आएगा, ड्राइव के लिए टाइमिंग क्या होगा। हमने बोला प्लीज गो थ्रू विथ टेक्निकल डेटा सी, 100% आपको आउटपुट मिलेगा। ऑन द बेसिस ऑफ दैट उन्होंने फिर एक बॉक्स मंगवा के भी उन्होंने आउटपुट देखा। उसका देखने के बाद उनको लगा कि हाँ फार बेटर है, कि एज पर टेक्निकल डेटा शीट जैसा आपने बोला, एडिशनल एक्सप्लेन करने की जरूरत नहीं है, उसके अकॉर्डिंगली हम चले थे, आउटपुट प्रॉपर दे रहा है। तो फिर रिफाइनरी में इसको लिया गया, फिर कंटिन्यू प्रोसेस में ये जा रहा है। तो बढ़िया प्रोस्पेक्ट है हमारे इस प्रोडक्ट रिगार्डिंग।
So now new tech team's audio is connected. Good. Okay, so Rick, he was just informing, Ranjit was just saying that, they have managed to sell around 1,000 Zinga Alu sprays to a refinery sector. And, the challenge which we face in India is that Zinga Alu spray is not as popularly sold as Zinga spray. And
Yes.
Part of the reason is a general fear about the zinc content, which is there in Zingalu being 90% zinc and 4% aluminum versus 96% for Zinga spray. So maybe today, once you finish your first part of introduction to corrosion, etc., then we can, highlight some of these queries which will keep coming from time to time. So that is the whole point. And I think it's 2 o'clock, so let's not waste any time. Good afternoon, John Galt, Zinga Technology Dealers. Good afternoon, Rick, and welcome to this first training of the year for Zinga, for corrosion, for coatings. And Rick is going to be celebrating 45 years in the corrosion and coating industry. So we should all give him a big round of applause.
Really?
45 years. I'm not 45 years. I'm sure most of us are 45 years. Bijoy is only 30 years old, so he's also not 45. And it's a good thing. Neil sir, we want to see how handsome you are. Please put your camera on. The most good-looking people always keep their camera shut. So hopefully Neilji will also put his camera on.
Not good looking. I don't know how to do it. 1 second, I'll just try.
Yeah, it's on. See, there you go. How are you,
Yes.
Neilji? I have not seen you for a while.
Yes.
You have seen all of these people. They are all your friends. So good. Tell them all hi. Good to interact with all of us. Great. So, we just came back from the US, and we realized that there is far more work in India because the assets under corrosion are far more. So, starting of the year, we are just in the second month. It's a good idea to revisit basics. So this is a back to basics class that will resolve everyone's queries. So Rick, over to you and all the best, and we are right here for you. Please start.
Thank you. It's actually, this year is 49 years, not 45.
Oh God, 49 years is brilliant. That is super, super. I'm really
sorry. Next April.
Next
April is half a century.
Yeah. So that you should be spending in India. I must say, we are going to make sure we do a big, maybe 100, 200 auditorium seating back to basics when your 50th year is there. That is a promise, and I will fulfill it.
Thank you, my friend.
Yeah. Over to you, Rick. Over to you. Yeah.
Okay. Good afternoon, ladies and gentlemen. I've been asked to do a bit of a training session for you guys. And I was asked to cover the basics of corrosion first. I've been asked just to cover the corrosion aspects first, so you understand how Zinga works. So I've got a corrosion, some slides to show you. Don't panic. We're not going to go into the atomic structure of steel. It's very basic, but it'll give you a very good idea of why metal rusts and how Zinga protects it better than anything, apart from hot dip galvanizing. So I've got to bring up this. Sorry, I'm not very.
So you click on share. Can you see the share in green?
Yes.
And click on entire screen. Entire screen is the top left. The first one selected is share. So just click on share then.
Okay. It's disappeared again. You can't see that?
No, not yet. So click on share again.
There's a share up there. Okay.
Yeah.
And okay. Okay. It's just uploading now.
Uploading. I thought it should just display it right away.
You cannot share this file till it's uploaded.
No, just click on share and share your screen, Rick. So don't go on documents, go on screens. The first option on the left is screens.
Okay, let me just minimize this again. Yeah, it's the share screen, and I have to go onto the I had to just click on the presentation. It should be coming up immediately, but it has to upload, it says.
No, it doesn't need to upload. So what you do is just click on share, and then on the top there are three options: screens, documents, and advanced. Can you see that?
Yes, yeah.
Just click on screens, and the first screen is entire screen.
Yes.
So just click on that entire screen and then click on share below.
So click on share.
Yeah, we can see it now. Yes. Now you can open the presentation.
Thank you.
Yeah,
I'm
so
so
now your
used to
mails are
Teams and
open. Yeah, your mails are open. So now you just select the presentation. What you can see, we can see. Yeah. Yeah. Now we can
perfect.
everyone can see the screens, right? Put a thumbs up if you all can see it. Yeah.
Everybody's happy?
Yeah. Let's begin. Yeah.
Okay. This is just the basics for corrosion, so you have a good idea what you're working with every day of your life. As you know, it's the deterioration of metal as a result of chemical, electrochemical reactions. So, in other words, your steel, every day your steel is reacting with the moisture. Okay, so even on days where it doesn't rain, because I come from Africa, so I know very well about rain and heat. But every single night of the world, anywhere in the world you live, you have overnight condensation. And many people forget this. And it doesn't matter whether you're in Saudi Arabia or up in the north of Canada, you still get wet metal every single night of the year. That never changes. And what happens is, in the atmosphere, you have a lot of carbon dioxide, millions of tons. This carbon dioxide, it dissolves in your overnight condensation and in your rain. It makes carbonic acid. And this is what attacks your steel. So if it's not painted or it's not galvanized with Zinga or galvanizing, it is going to corrode. And it's basically, when it's corroding, there's little molecules of bits of metal are actually dissolving into the water. And that's assisted by the carbonation from the gases. So that's very basic what it is. Another good example for you is chimneys. All over the world, you see chimneys, especially when you're making steel and so on. They produce sulfur smoke. And again, the sulfur smoke, when you have rain coming down and again, overnight condensation, sulfur smoke dissolves into that water and makes sulfuric acid. So that's also what eats your steel. And I had a guy phone me up a couple of years ago and he said, we have corrosion all over our bridge after only 12 years. Can Zinga work? I said, yes. He says, you don't understand. He said there was some paint damage with a truck. It took off the paint and it started corroding. I said, yeah, it's your salts. He says, no, we're more than 200 kilometers from the sea. I said, you know the air you breathe? It's 20% nitrogen. Okay, and like sulfur and carbon dioxide. Nitrogen dissolves in the rain or the condensation, and it produces nitric acid, which is a form of salts. So he was quite amazed, and I said, it doesn't matter where you are, you're going to have water and you're going to have salt forming, and the salt is going to attack your steelwork. It's as simple as that. And it's also two different steels, but we'll cover that as galvanic protection. So yeah, and when you speak to scientists who work with corrosion every day, the big thing for them is time of wetness. So if you have metal that's dry and it gets wet one day a year, that metal will last 100 years. But when it gets rained every single day, yeah, then you have your reactions taking place because the water's there. And once the water's there, you will have reactions, and then it dissolves quick. Your steel just eats away and disappears. So basically, this is the circle of life. So you can see on the top there, they have a factory making steel. Okay, well, your factories make iron first, okay, and then they take the iron, then they put it in carbon, and it becomes steel. So when it becomes steel, now you can bend it, you can weld it, you can drill it, you can do anything with it, because steel is very, very flexible, as you know. So the next part of the life, sorry, I should have explained when they make the hang on, I've got it on a slide here actually. There, when you make the iron, you get this red dust called ferrous oxide, and you dig it out the ground, and it goes into a big blast furnace, and they extract the iron. Okay, and then they add the carbon to the iron to make steel. It can be rolled, pressed, welded. But once it becomes steel, it's very active, okay, because carbon, you've seen it in your torch batteries and all these things. It's the carbon that's doing all the work. So once carbon's into steel, it's very, very active. And once it becomes steel, believe it or not, it becomes one of the most unstable metals on Earth. When people look at a piece of like a piece of steel, you know, they think it's just a piece of dead metal. It's not. It's active, and there's nothing you can do to change that. Everything is active when it's metallic. There's always little electrons, little charges trying to flow through it, and of course, as I said, it will react to atmospheric moisture and salt and oxygen. So the circle of life. You take the ferrous oxide, you make your steel, you make it into cars, fridges, beds, gates, whatever. And as it gets old and the coatings break down, it rusts. What happens? It forms ferrous oxide or rust. So you've actually gone a full circle from mining the ferrous oxide. It goes all the way around, it becomes ferrous oxide again. So to break the cycle, that's why people put paint, or in our case, we put Zinga. And other guys put hot dip galvanizing. It breaks the circle of life of the steel and makes it last that much longer. So this is how everybody sees a piece of brand new steel. And the thing is, it's just a piece of dead steel. But it remains active 24 hours a day. And your steel will develop anodic and cathodic areas. Okay, so anodic areas is where these little charges begin. And that's normally where the carbon is. And these little charges will flow from those areas, but they stop because there's nowhere to go. So I'm just showing you here in a basic diagram. All your little electrical charges are flowing from the anodic area through the steel, and they stop. And this is how it looks. If you could see that steel plate through a special microscope or whatever, you would see these little charges. So all the plus signs is where your carbon is in the steel and in cast iron as well. A lot of carbon in that. And it's just flowing and stops. Sorry, this will be repeated. So this is like me. I'm just showing you that cycle in the steel. It's like if you have a battery to a light bulb, and you undo one of the wires, the light bulb will not come on because there's no circuit. Okay. As soon as you put water on steel, any water, like I said, rain, overnight condensation. Now you have a circuit because the electrons are going to flow from the positive area to the negative as normal. Then they're going to flow back to the positive through the water. And there's your circuit. And that's called a corrosion circuit.
So this
So
happens.
that's the
because-
same as,
So this happens because the water acts like a reverse route for the current to flow, right?
yes, exactly. So actually, in scientific terms, the little charges going through the steel are just called electrons, but when they flow through the water, they're called ions, but it's still an electrical charge, and that is your corrosion cell. And this is what Zinga breaks, but we'll show you that in a sec. So what happens when you see steel? Anywhere you have the positive area and the electrons are flowing away from it, it just starts to deplete and form pits. And you see little bits of pitting all over the steel surface as these little areas develop. So very basically, you can see these are the active areas for the plus signs. That is where the rust starts, and it starts to eat into the metal and makes little pitting, little holes in the surface. Then eventually it spreads over the entire surface because there's so many little rust pits. There's no gaps in between. So, and this is how it looks. So when we put Zinga on, there the top plate is showing you the steel as it is, just an empty steel plate. But see underneath, that gray color, that's the Zinga layer. And automatically, the current flows from the Zinga into the steel. So the entire Zinga area becomes active. That's a big layer of plus signs, positive. And why? Because all metals, as soon as they're made, they all have a electrical potential, believe it or not. So zinc has an electric potential of just over 1000 millivolts, and steel has a potential of roughly 640 millivolts. So that extra 500, 400 millivolts on the zinc, it's like if you fill a water jug full of water, if you keep pouring water in, it's going to overflow. Well, that's the Zinga. It's got so many electrons, it overflows into the metal, and it'll continue to. As soon as zinc's in contact with metal, the electrons are going to just flow into it automatically, because it's like filling an empty jug with water. And this is why galvanizing has been used for 150 years, because as soon as you put the hot zinc onto the steel and it cools down, the electrons just keep flowing. And as long as there's zinc there, it's like you keep on pouring water into the jug, it's going to keep overflowing. As long as you've got zinc on that metal, the electrons are going to keep pouring into the steel. And that's physics. It's nature, you know. That's what's so amazing. You cannot change that.
So just one question. If you put a paint layer, what happens in that case? A layer of epoxy paint or polyurethane paint or anything, does it have the same effect?
No. What actually happens when you put the zinc on, because it's an active coating, it's pumping in the electrons. If you put a layer of paint onto the top of the metal, all that's doing is stopping the moisture from getting to the surface. And also the oxygen helps the reactions work quicker. But as soon as you put paint on, this is what we call the barrier coatings, because all they're doing is acting as a barrier to the moisture. If there's no moisture, there's no current. It's as simple as that. So corrosion is not that hard to understand when you look at it from this point of view. It's very, very basic. So yeah, all coatings, it doesn't matter what they are, all coatings are barriers. Even many zinc coatings like zinc epoxies. From a chemistry point of view, it's a complete waste of precious zinc dust, because they just sit there as a barrier to stop moisture. They're not putting any current into it. Only Zinga, hot dip galvanizing, zinc thermal sprays, they're active. And they're all putting the current into the steel. I'll just show you the different corrosion types. Okay, we're going to look here very basically at the different 10 main types. Okay, you get general, which you saw on that panel. The entire surface is covered with rust. That's general corrosion. Then pitting corrosion, which is localized. So those plus and minus signs are very close together. So your little corrosion cells operating in a very small area. And that's why the pitting goes deeper and deeper, which often you see on pipes, water pipes, pipes in oil refineries. When they start pitting, then you know it can be dangerous, because after a certain point, it's going to eat a hole right through the pipe, and then you got oil, gas, water, whatever coming out. So pitting is the one you got to keep an eye on. Again, galvanic corrosion. That's literally how Zinga works and hot dip galvanizing and so on. Whereas one metal will corrode in favor of the other metal because of all the electrons flowing out of it. Then you got fretting, filiform, stress, and so on. But let me show you. So this is the common one. And as I just showed you, you develop little rust spots all over the surface. And because it's general and the entire surface area is exposed, it'll all corrode evenly at the same time. So this is general corrosion. With pitting corrosion or localized corrosion, like I said, this happens in a very small area. So your plus and minus signs are very close. So your circuit is very small and concentrated. So all the energy is going into that one area and it starts to dissolve the metal out. And for example, you'll see often on pipelines, tanks and so on, if they've had damage or if they have the paint is just broken down with age, because all paints break down, okay? There's no such thing as a perfect paint. The ultraviolet is the main culprit. Once ultraviolet starts hammering onto a paint system, you can normally tell when it's breaking down, because the first thing you see, it goes a little bit matte and so on. Then it starts to flake off back towards the primer and back towards the metal. And what happens with pitting, the paint will break away in a small area, and that area is where all the water goes from your overnight condensation or whatever. And that's why that area, it starts pitting and it goes in very, very deep. And that's why we say on pipelines and so on, if you've only got small areas of pitting and the customer doesn't want to spend thousands and thousands of dollars, if you have a bristle blaster or something and just treat the area where the pitting is, brush on Zinga, that'll fix it for the next 10, 15, 20 years, depending on how thick the zinc is.
So I have a question.
So,
I have a question here. So
Yeah.
many times, first of all, dealers, have you all seen such a photo in real life? Have you all seen pitting before ever? All of you all must have seen it somewhere, right?
Yes, pipes.
Yeah. Yeah. So Rick, the question here is, and I'm just speaking from a point of view of an applicator or an end user. I'll say that, okay, I'm just going to put, I'll just, clean it with a brush and then apply a paint and then I will leave it. So my problem is solved. So what happens in that case? Because this is what all our customers tell us who are not educated about galvanization.
when they're putting on a paint, sometimes, well, often, if they haven't feathered in the edges around the repair area, sometimes the paint won't bond properly and it can lift and it can fail very quickly. We've seen it often failing within a year. Then they've got to go back again and redo it. And it takes a lot of manpower, and a lot of money, wasted time. And also, if the paint, this is another big issue. If the original pipeline or tanks or whatever it is, if they were coated with a 3-layer epoxy system, very often when they repair it, they don't put 3 layers back on. They just put on a top coat or a bit of primer and then a bit of top coat. And that will never last the same as the surrounding paint. It'll never, ever match up to the durability. And we always tell guys, if you do a small repair, and if it's a critical repair, for example, next to a valve or a flange on a big gas tank, and you've got corrosion, that's critical, because if that breaks down there, it can be catastrophic. So we said to the guys on those areas, and even on steel bridges, you may have a main support beam with the bridge bearings. That's also critical. And we say, if you go in there, even using a bristle blaster and Zinga, that repair area will outlast the entire coating system on that structure, whatever it is. It'll outlast it by 10, 20 years. So that area is completely secure.
So if you notice,
So
if you notice what Rick said, dealers, he's saying even if you do bristle blaster, you all have seen bristle blaster, right? It's basically it's a rotating tool, which is like a wire brush, which is used to create roughness, and as a result, it cleans the surface, and then you apply Zinga. He's saying that portion can outlast the non-pitted portions also. So I hope you all are paying attention to that. This is the so-called potential that Zinga has. Yeah, please go on, Rick.
Okay. Yeah, so on some structures we've seen over the years where they They see an area that's critical, they'll repair it. And then after a couple of years, there's another area, then another area. And all these areas will sit there for years and years and years. And they won't cost them a penny because it's fully protected. And so we also have sometimes, we have like in Malaysia, ExxonMobil, they had many areas and they said, we want to reblast these areas, but we want to reblast them only in 5-6 years when we have the budget. In the meantime, we want to stabilize these areas. We don't want to have any more pitting of that. So I was asked to develop a very simple system. Okay, and they said, we want a simple system. We don't want tools, nothing. We have a lot of guys who are not highly skilled. So I said to ExxonMobil, what are you giving me to work with? And they said, a wire brush and the Zinga spray. So I developed the frontline maintenance system. And it's basically the guys, and this is based on science, believe it or not. So when you have a rusted area, especially on a pipeline and so on, if they wire brush it and remove the top layer of rust, which is an orange color, if they remove that and underneath is a darker, deeper brown color, the top's orangey yellow, the underneath's darker brown, that rust is older and it's well established and it's really got a fantastic grip. And he says, so you do that, just take a new paintbrush and dust it all down, then aerosol, okay? Let it dry for 20 minutes, another layer, and get it as thick as you can that day. So you do different areas. Now what happens, because the zinc particles of Zinga are much smaller than the particles of rust, it actually penetrates down through that rust, believe it or not. And Zinga has a throw of 15 millimeters. So it can project the electrons up to 15 millimeters away from where the zinc stops. So these guys at ExxonMobil said, that sounds incredible, but you know, we have to see that. So Gurmit, you know, he organized it and he asked ExxonMobil for a big sheet of steel from their yard. We didn't create anything fake. It was a genuine steel. And he cut some big panels and they wire brushed. They dusted it all off, sprayed on the zinc. And I said, now the important thing is don't leave it in a laboratory or whatever. You leave it outside, okay? This is real world. And what happens with Zinga, when it gets wet with overnight condensation, it gets harder, quicker, believe it or not. It's one of the coatings in the world. Actually loves water. So we left it for 7 full days outside in the rain and so on. And Gurmit even went out and sprayed it with his hose to make sure it was soaking wet every night. When ExxonMobil went to do it's called tensile pull-off testing, so that they glue on dollies. It looks like a pawn from a chess game. It looks like a pawn. I don't know why. And they glue these all over the panels. And they said, what do you expect? I said, maybe 6 megapascal, maybe 7. They said, on rust. I said, yeah. They said, if we blast clean steel and put epoxy, we're hoping to get 6. I said, yeah, that's epoxy. When they did the testing, I wasn't in Malaysia at the time. And Gurmit Singh, he phoned me and he was crying with laughter. And I said, what's so funny? He said, you know, or VJ, the head chemist, he put all the dollies on the day before, did everything by the book. And they had a machine that were pulling off the dollies. They were stunned. They got 12.2 megapascal, which is double what I predicted.
Amazing. Yeah. And Neil, you want to talk about one case where, you know, your customer had applied, you know, on some galvanized portion. There was some staircase in a mall. Neil, can you highlight that example when you had that case? In some mall, you all had applied Zinga or they wanted a reapplication. So let's discuss what was that issue, if you can highlight. You're on mute, Neil. Neil, can you unmute?
Hello. Yeah.
Yeah.
What is it? What is it you said?
You had one case, right, where you know in some mall staircase in I think town or fort, there was an application and it was already corroded and something like that. There was a case, right?
Right, right, yeah.
Yeah, can you just give a little highlight about what was that case exactly?
They had coated without, I mean, proper surface preparation, and water was flowing on it, and certain areas were getting corroded. So the areas which were not properly treated, or the surface preparation was not made, in that cases there was problems coming, and then ultimately we went there twice, thrice, and then informed them accordingly. This is the reason why this is happening, and other areas were not that of a problem.
So initially they had applied Zinga or they had applied something else?
No, they had applied Zinga only.
Okay, but the surface preparation was not up to the mark.
Right, right, right.
Okay, yeah, yeah. So many of us, I think, how many dealers face this problem where they buy Zinga, but they don't do surface preparation properly? If you all have come across that case, you all can raise your hands that your customer has purchased Zinga, but he is not doing the proper surface preparation. Ranjit, are you all facing that problem in Gujarat? Sujoy, what about you? Bijoy?
No, no, as such, nothing. But yeah, deposit in rainy season, deposition of zinc salts. Customer sometimes gets alarmed. What is this salt formation? Then we explain them. This is normal.
Okay,
Impression is fine.
okay. Ranjit, what about you? Any time you'll have faced this problem that the surface has not been prepared correctly and then it has been applied?
Some problem overcome down, but I have suggest to client, please do preparation before applying a Zinga. Please go through our technical data sheet for preparation and itself. After that, result will come down better.
Okay. Bijoy, what about you?
Yeah, the main thing is the surface preparation. There only during the trial, our sample, we have faced the same issue.
Yeah,
Okay. Some of the areas we couldn't clean it thoroughly because of the site conditions, because
correct.
height and other conditions. That area only we have faced the same issues.
Got it. And Rick, I'm sure once you cover the types of corrosion, you will also throw some light on surface preparation through non-blasting options, right? Because see, what happens is Zinga is ideally where as a repair system, and wherever the sites are, the surface preparation through blasting or copper slag blasting is difficult. So in those scenarios also, once you are done with it, please cover that as well. Over to you, Rick. Over to you.
Okay, will do. No problem. Okay, that's pitting corrosion. This is another very, very common crevice corrosion. So anywhere you have bolted joints, if you have two plates bolted together on a bridge or whatever, and as you can see here, even between the nut on a bolted plates as well, anywhere you have two pieces of metal together, you're going to have water going in between the plates again from rain, overnight condensation. It's always there, this moisture. It goes in between the two plates, and the surface, it's okay, but see deeper down, there's no oxygen, and believe it or not, that turns the moisture acidic, so your pH starts to drop. And even if they're painted and it's old and it's starting to break down with age, that acidic water will go inside, it'll start corroding, and it starts swelling up with rust. We've seen on transmission towers where it's actually buckled the angle iron. They make the big towers from angle iron. It's actually pushed the angle iron out so much, it's twisted the plate from the pressure of the rust. It's incredible. And of course, the bolts inside these bolted joints, they just rot through. You hit it with a hammer, the whole thing comes apart. On the left, you will see there, that's a welded joint. So you have two plates back to back. Okay, so the inside is where the angles are, and you're seeing the outside face here, and the moisture's gone inside there. Okay, if you have rain going down and there's a gap, through capillary reaction, it will suck the water into that gap, which is, again, it's a natural phenomenon you can't change unless you fill it with sealer. So that it'll go in, it'll corrode, and then the first thing you see a rust standing running down. And sometimes you have a big tank or a bridge or something, it looks fantastic. and then rust staining is running down from a joint, it ruins the whole appearance, and it could be a very small area that's affected. So on that one, on that joint, if you even just wire brushed it really vigorously and then thin your Zinga down 15% or use Zinga spray and put it inside there, give it 2 or 3 coats. As the Zinga cures and dries, overnight, it actually expands and goes a bit thicker, and it'll seal that joint completely. So no more moisture can go inside. Because we have guys saying, oh, we're going to blast it or wire brush it, put the Zinga, and then we're going to put Sikaflex. I said, if you put Zinga on there 2 or 3 layers, you don't need any sealant. You don't need Sikaflex. It'll seal itself. So galvanic corrosion, as I said, this is exactly what Zinga does. Zinga's corroding to protect the steel. But for example, we had a job where we did the roof beams on a big factory in Ireland and with Zinga, and there was 9,600 holes. So they did all the beams and they're ready to start putting up the whole structure. And luckily, on the last day I was there, I was being very nosy, and I went to look on this pallet from a truck had just arrived, and I opened the box, and inside was the 9,600 nuts and bolts for the roof. And I said to the engineer, I said, oh my God. He said, what's wrong? I said, look, every one of these nuts and bolts is stainless steel. He said, yeah, that lasts forever. I said, that's very bad. You never mismatch metals, okay? All these beams you've galvanized with Zinga, and they will last, well, under a roof, they'll probably last 80 years. But if you put stainless steel, when they sweat, because these were curing sheds for peat, very, very steamy. I said, the zinc around all the bolts, the zinc is going to dissolve, excuse me. So the electrons are going from the zinc into the stainless, as they do with normal steel. They're going to start dissolving to protect the stainless steel from the water. And I said, within 3 months, all 9,600 bolts will have a round mark turning slowly, slowly brown as the zinc disappears. It'll dissolve around every bolt head. I said, all those nuts and bolts should have been galvanized. And you can buy these things anywhere in the world, galvanized nuts and bolts. So I said, you've got to exchange these, or you'll come back in 2 years and your men will have to change 9,600 bolts on a roof. And that'll take, what, 2 weeks? It's a lot of money and a very expensive mistake. So galvanic corrosion, it takes many shapes. We've had guys bolting aluminium frames onto steel structures when they're putting in a roof to keep a light weight for the aluminium. And I said to them, the aluminium is going to dissolve to protect the steel. You must not mismatch. In some cases, they've even lightly blasted aluminium beams and sprayed it with Zinga, and then bolted it onto galvanized beams with galvanized bolts. So all the metals are touching are the same. So galvanic corrosion, it destroys so many things around the world every year because the guys don't have an understanding. And it's the same in boats. We have guys who have, as you know, on boats under the water, they put zinc anodes or aluminium anodes, but you've got a stainless steel prop shaft to the propeller. The propeller is often made of brass or stainless or bronze. And I said to the guys, you know, whether it's atmospheric or underwater, you must not have a metallic cocktail, as we call it. Because a metallic cocktail, all the metals that are more active are going to dissolve and disappear. So you've got to have the same metals always on any job. This one is less common, but it still happens around the world, is fretting corrosion. So when you have this fencing, and it was a very expensive fencing, and you can see in the middle where where it's starting to dissolve, the metal is dissolving. So what's happened is with high winds and they've got cattle and sheep going through, so that fence is vibrating a lot. And as it vibrates, it's rubbing against the upright pole. These are like 12mm bars, and they're coated. But because of fretting, it's rattling around them, and it's eating away the paint, and the corrosion's coming in because every night it gets wet and it's eating through it. And you can see it's already shrunk by about 2 or 3 millimeters. So in another 2 or 3 years, at a certain point, that centerpiece is going to snap because it'll lose all its strength. So fretting corrosion is an issue as well. Filiform corrosion is not so common, okay, but if you see it, this normally happens when you put on a very thin layer of paint, and especially oil-based paints. And in Africa, we use them to paint our window frames, doors, and all that. And it's normally an oil base. And the oil, even an unbroken coating of oil paints, it allows corrosion to form underneath, believe it or not. So filiform corrosion, that's a little telltale sign. So I can see next week, if you're shopping with your wife, you're going to look at all the different metals around you, and you can identify which one is which. This is what many Zinga wives suffer around the world. Stress corrosion cracking, we found this on rail tracks. Okay, we were the first country in the world to coat our rails with Zinga, because in summer they spray salt all over the road. And of course, salt mixed with rain and condensation, it just eats away the rails at all the level crossings, especially because that's where the salt goes. But apart from that, we see the constant flexing of the rails. I actually did a presentation on Rail Malaysia about 6 years ago on this topic. So when, especially on curved sections of track, where all the wagons are going all day long, and those curved sections are under constant pressure from it, and these cracks take place at the bottom where your wheels run, at the bottom of it, of the rail track, between the bed and the upright, the web, it cracks there. And this is because it's flexing so much, you get a fine surface crack. Then you get condensation going into that. And as it's working, the energy is making the water more reactive, and it starts eating through, and the crack goes deeper and deeper and deeper every month. When you put Zinga on there, it actually stops all those activities inside the crack. So the Zinga is inputting its electrons, and it stops the damage caused by the water. So it's used in some very, very unusual areas. High temperature corrosion is another one. For this, we use aqua Zinga. We've just done a big job in Pakistan with 6 chimneys, and I forget how much aqua Zinga it took, but wow, it was a big, a big project. And again, this is slightly different. You do have reactions where the atmosphere is normal, so carbon dioxide forming carbonic acid, but the heat also carbonizes a lot of fumes, and these go inside the metal, and then it starts to striate, it splits, and it starts peeling off. They call that scaling. So when we put aqua Zinga on top and seal it all, it stops any reactions from moisture or from the gases taking place. So we have a solution for virtually all of these. Microbial corrosion, the first big project we did in Killybegs in 1999, they had 312 pier legs on this. It's the biggest pier in Ireland, and the ships come in and they unload their fish on that pier, and these 312 legs support a concrete deck, and on that deck is a big fish processing factory, and you get ships from Russia, Finland, will come in every Friday and they load up with fish and disappear. So I was called in and they said, look, this factory and these legs, we were told it's a 50-year design life. Okay, each leg, the wall thickness was 40 millimeters, and we x-rayed many legs, and it's down to 16 millimeters from 40 after only 20 years.
So
And
from
they said
40,
you have
from 15 to 16, 40 mm to 16 mm.
yeah, from 40, yeah, down to 16. And I said to them, you see, the water is a bit shiny. He said, yes. I said, I think the fish factories maybe putting some of their scraps in the water in the harbor. They said, no, they assured us that they get rid of it, biologically, and they use it for cattle feed. I said, you see that water? It looks like a kaleidoscope, greens and blues and purples. That's oil. That's. And so what happens with microbial? This happens all over the world, eh? Even in India.
So the hint is if the water starts appearing a little shiny, that is when you are suspecting it, because rays of the sun are falling onto the metallic substrate, right?
Yeah, the oil just gives you that sheen on the water, you know. And what so basically what happens when you get oil from factories, even from exhaust from ships, all that oil in the water, it goes onto metal, and it's all sticky at low tide. And makes a sticky mess, and that actually forms a biofilm. Okay, it's just a sticky mess on the metal, and these microbes are quite amazing because nobody knows for sure how they know that that muck is there, but they seem to migrate there within a month.
Yeah.
And because they're anaerobic, they don't need oxygen. So these microbes, they go into the oil and they go through it and they go behind it. They
Yeah.
actually feed off that muck. Okay. And these bacteria are called sulfate reducing bacteria. So what they do is they eat all these sulfates, and that's in the oil and in the muck, and they produce, out their backside, they produce acid. These microbes eat 2 millimeters a year of steel, believe it or not. So microbial corrosion is very aggressive. It's not only for ships and for harbors. We've seen it inside water tanks. So if you have a water tank that's been disused for maybe a couple of years, microbes, I don't know how they get in there, but they get in there, they start eating through the tank walls because they love stagnant water as well. So where the water is very stagnant and got a bit slimy, green, the microbes in there can start eating through the tank walls. So microbes actually appear in many different areas. And what's amazing, we see people in harbors with the sheet piles all that they put anodes, and the anodes don't only protect the metal from the salty water, it actually protects them from the microbes. And these microbes, they're called electron receptors. So the electrons flowing from the zinc into the metal, they receive that into their bodies, but after a few days, it actually poisons them. They stop eating, then they stop breathing. So instead of colonizing all the metal, they start dying off. And within a couple of months, there's no more microbes. And we told this to the guys in Ireland, and they said, okay, so you're going to galvanize all the legs with the Zinga? I said, yes. And what top coat? You're going to put epoxy and polyurethane? We said, no, there's no top coat. And they said, you must be crazy. These legs are covered completely at high tide and then completely exposed at low tide. So they're going to corrode like hell. I said, no, they won't. I said, Zinga has an oxide layer. And over the weeks and months that follow the application, it gets harder. The adhesion gets harder and tougher, and it carbonates. I said, the carbonic acid formed from the carbon dioxide and the overnight moisture, that combines in Zinga to form a carbonate layer. It's called zinc carbonate. It's very tough. They said, we can't believe the zinc can be that tough. They said, we want to ensure this project. So we said, okay, you can speak to SGS or AG in Germany. They guarantee many of our projects. And if you speak to AG, they will tell you Zinga is the only international paint company who's never had a claim. You speak about Jotun International, Hempel, Sherwin-Williams, all the big boys. They've all had claims for millions over the years. In 35 years, Zinga had not one claim. So I said, okay, we'll insure it. This month, believe it or not, is the 25th anniversary of the application, and the Zinga is still there.
Excellent, excellent.
So they were stunned.
I want to highlight two things. Dealers, if you all noticed, what Rick said was, there have been no insurance claims. So if you know, Zinga Metal gives a warranty on the coating, provided it is applied correctly and it is witnessed by a NACE level 2 inspector with proper documentation. So what we are trying to see is just that the surface preparation and the application is done in a correct manner. So, that is one thing which I want to highlight. And Rick, I'm going to just stop the sharing for 1 minute because I have a quiz for my dealers and they are going to win some prizes. So the idea is to keep it engaged. And so are you ready to take the Zinga quiz, dealers? If you all are ready, put your thumbs up, all of you all. Yeah, all of you all are ready. Okay, Ranjit, your thumb is blocking the screen only completely. So if you all are ready, basically there are going to be 15 questions and one champion. How you win is you have to reply the answer 1, 2, 3, or 4 quickly on your respective WhatsApp groups that you have with us. Rick, you can participate in this as well. And the winner who answers correctly and fast will be winning overall 1,000 rupees. And 1,000 rupees will be credited in your GPay. So idea is you should know your technical data sheet very well. So Neilji, are you excited? Want to play a quiz? Yeah. Should we start? Okay. So I'm going to display 3 questions. Rick, you need not answer. You can just laugh about it. Okay. Here we go. So the first question is, what is the primary function of Zinga? Is it A, passive corrosion protection? Is it B, cathodic protection of ferrous metals? Is it C, insulation against high temperatures? Or is it D, chemical resistance against acids? Once you all have answered, just put a thumbs up. Once you all have given the answer. Okay, answer has been given. Answer has been given. Answer. I don't know whether Bijoy is playing or not. He's not reading. I can't see him. So this was the first question. I'm going to take three questions at a time. So Rick, maybe it's a little break for you because you must be getting tired, speaking continuously. So you can maybe have a,
I'm gonna make some tea.
yeah, you can go ahead and make some tea. No problem. So,
Okay.
are you ready for question 2? Okay, question 2. What is the zinc content in the dry film of Zinga? Quickly.
96%.
You don't have to tell us the answer. You have to just send the answer. Okay, second one, everyone has answered. Ready for the third one? Okay, third one, here we go. Which standard does, this one is complicated. This is not going to be easy. Which standard does Zinga conform to for zinc purity? So this I'm interested in seeing. So don't answer on this group. Answer on your respective groups. So you can re-answer. Okay, I'll reset it, but answer on your respective groups. So for example, Maharashtra, Goa is Neol's group. East is Sujoy's group. Gujarat is there and South is there. So yeah, answer it in that group, please. So which standard does Zinga conform to for zinc purity? Very interesting. Let me see what you are answering. Okay. Neil, you seem to be correct. Ranjit, I don't know what. At least you all are going to look at the technical data sheet, right? Because of this. No, it's an open book. You can definitely look. Ideas to find it fast. Okay. No, Ranjit, that's not the right answer. But anyway, I'll move on. So you can always look into it. Okay, ready for the fourth one? Okay, fourth question. Which of the following methods is not recommended for surface preparation before applying Zinga? This is a little complicated question, okay? So I'm keen on knowing, Neolji, you will, can you put your answers again? Because I've got 2 answers of yours. So can you put that 1, 2, 3, 4 again? Just write 1 is so and so, 2 is so and so, 3 is so and so, and 4 is so and so. So that way it's fine. Have you all answered this question? Ranjit, why are you blocking the camera? I can't see you only. वो फोन गिर रहा है तो सपोर्ट दे दो उसको. हाँ. So have you all answered the first, fourth question? Okay. Bijoy, you have not answered the fourth. You have answered the third.
I am driving here.
So
Not
why
able.
are you driving? Forget the drive. Keep a driver. Okay. And I'm going to give the 5th question now. Ready for the 5th question? Put your hands up. Nehul is not ready. Nehul, okay, Nehul is also ready. Fifth question. What is the maximum temperature resistance of Zinga and dry film for in continuous exposure? Akhilesh, do you know the answer? Where's Akhilesh gone? Akhilesh? Are you there? You are there. Okay, good. Yeah, I can see. Akhilesh, you also answer, huh?
Okay, sir.
See,
Okay. So this is the fifth one. Okay. Should we take one more before we take a 5-minute break? Yeah, Nehul, one more. Okay, one more question coming up. What is the recommended relative humidity for applying Zinga? Is it 80, 85, 90 or 95? How are you all finding these questions? Easy, tough?
actually, I think the right frame of question is not recommended. What is the maximum at what relative humidity can the Zinga be applied? That is what I think.
You are right, because you know how I made this quiz? I went on ChatGPT. I uploaded a PDF. I said, give me a challenging multi-choice question using this data sheet. I just copied what is there. So
Good one, good one.
that
Okay.
is there. So good. So 6 questions. Now, Rick, do you want to review what questions we asked and you want to give them the answers?
Sorry, Abhay?
So you want to just see what questions we asked. We asked them what is the primary function of Zinga, and there were 4 options. And the answer is B, obviously, cathodic protection. Next question is what is the zinc content in the dry film thickness? The answer is above 96% ideally. It's usually more than 96. Third was a little tricky. Which standard of the Zinga conform to for zinc purity? So we got some answers as 14,001. But the actual answer is ASTM A780, right?
Yeah.
Yeah, because this gets very confusing because some of them feel because we are having we having some ISO standard, so they confuse 14,000 with 12944. 12944 is the corrosion area standard. It's not related to zinc purity. Zinc purity is ASTM A780. Fourth is, okay, Rick, you want to talk about this one a bit, that which of the following methods is not recommended for surface preparation before applying?
Yeah, shot blasting.
Yes. And why is it not recommended?
There's a couple of reasons. With shot blasting, and many automatic machines use metallic shot, which is round, like the buckshot from a shotgun. And so they should look like small ball bearings. And shot blasting is okay for breaking mill scale and stuff off new metal because it shatters it and it stops it from coming loose after a year or so it's removed. But shot blasting gives you a surface like a golf ball. So instead of being sharp, jagged peaks where the coating can grip, it's all smooth. So it has no lateral support at all. And it's so your adhesion is very low. So your pull-off strength is also very, very low. So shot blasting is we never ever put anything over shot blasted surface. It's very bad.
Got it. Then one question we asked was what is the maximum temperature resistance of Zinga and dry film in continuous exposure? So it's actually 120 degrees with spikes of 150, right?
That's correct. Yeah. Just so you know, when they decontaminate nuclear steelwork that's been coated with Zinga, they use superheated steam at 150 centigrade on the jets to decontaminate the Zinga surface. So, yeah.
Great. And then I asked one more question where Nehul pointed out what the question should be, what is the maximum relative humidity limit for applying Zinga? And Nehul, what was your answer for this?
95%.
95 D.
Yeah, so is that correct, Rick?
It is indeed, yeah.
So good, our dealer. So this is part one of the session. Now, Rick, over to you. I think you have finished the types of corrosion so far, right?
Yeah, there's a couple left, but if you've seen enough about corrosion, we can go on to the metal preparation.
Yeah, let's do the metal preparation. Yes.
Okay, I've got to
Until then, you all
find
can
it
take
now.
a quick 2-minute break and then come back. We'll resume in 2 minutes. It's 2:57. We will start at 3 o'clock sharp. So you all can take a quick bio break. Rick will be back in 3 minutes.
Okay, thanks, Abe.
Rick, you can load up your screen and keep ready to save some time.
Yeah. I forget how I did it last time now. It was yeah. Whole screen. To that screen. Go to here. Two, one.
Ini boleh ada kita.
One there.
Tak ada tujuh dan berkat ya.
Okay, let's start. Rick, you want to share the screen now?
Yeah, I'm just trying to
Go on
I'm just
share
trying to get
again.
back into the
Yeah, go on share, go on screens
yeah.
and select that entire screen option.
Yeah,
India,
it's bringing up
India,
it's bringing up two of them, but it's not bringing up the third one. But they're all there.
What do you call
Okay.
reception?
I don't
Just
understand.
select the entire screen option.
वो कटो करता हूँ ठीक है
Just select the
So
entire
I'm going
screen.
up to yeah, that's the
Yeah.
entire
Yes, there you go. Yeah. So guys, are you all ready?
it came up.
Can we start again now, please?
Yes, sir.
Everyone, please take your places and let's begin. This is very important surface preparation. Let's go.
Oh,
Everybody there?
Yes, we
Okay.
can start.
This is assuming that this is a new job. Okay, we'll cover other ones later. So the steer work is the same for most coatings. Okay, blast cleaning. So we tell customers when you're using Zinga, you don't use any different equipment or different processes. It's exactly the same. So there's no extra cost involved. Applying Zinga, like even applying thermal coatings, it's exactly the same process. Okay, this is the sequence, always on all brand new work. Edge radius, pre-clean, blast clean, de-dust, and the application, and then the flash rust. Okay, so edge radiusing. This is a very important thing. That should always be the first step, because sharp edges are bad news for any coating, right? Because what happens is all coatings have surface tension. So if you apply it onto a sharp corner, as the coating dries, it's going to pull back from that corner and leave it half thickness. So sharp edges are never ever to be coated where possible. It's the same importance also for dressing off welds with weld spatter and so on. So all these systems have failed prematurely, these coating systems. And many have only failed at half. So if we said, yeah, this is a 40-year life and they don't do the preparation correctly, 25 years it fails. And then there's big costs involved. So, and recoating will be triple the cost. So now what's happened, what we've seen in recent years is that the steel manufacturers, they actually supply steel with radius corners now, as shown here. So some radius, both edges, not only the top, like you see here on the bottom. On the bottom of this channel line, that they've only radiused that top face. Many manufacturers now radius both faces so that the entire channel is rounded off. And the only sharp corners you will have is where you cut the steel. Then let's just take an angle grinder with a sanding disc. Okay, not a grinding disc. That makes a mess. You just take a sanding disc with something like a 40 grit disc or a 36 grit disc, run it along the sharp edge, down that edge, down that edge. It takes literally 20 seconds, and you have a nice radius. Internationally, they look at 2 millimeters or 3 millimeters. 2 millimeters is fine. So yeah, on a cut edge, you still treat that before you do any blasting or pre-cleaning. That's vital. So this is just to show you, that's the sharp shoulder, and that's where the coating will pull back on either side of that sharp edge. And again, that's natural. Okay, that's the laws of physics with materials. And also when you're trying to blast it, you can split the blast. So you might have an area that's slightly smoother along the edge of the beam, which you don't want. So you can see here what happens. The coatings pull back, and it's roughly 50 to 60 microns maximum you'll get on a sharp edge. And what happens there on a coating, that area will break down very quick from UV. And in the case of Zinga, if there's any other influences around, any other adjacent metals, whatever, that thin area can deplete quicker than the rest. So the 100 microns might give you a good 30 years, depending on where you are. But the edge, you probably only get 15, 20 years, and then you're going to have to redo it.
So, Rick, this is a very true case. This is very true. We are doing heavy fabrication. We have seen that on channels and angles at the edges always, because they are using spray paint. The coating does not fall enough, it does not disperse enough. And if it's going to be sharp, it will never be uniform. So some radiusing is always preferred, and applying with a brush is recommended at the corners. Yeah.
Yeah, absolutely. Yeah, so that's opening up the edge now. It's much easier to profile a radiused edge. It's very easy, in fact. And coating as well. It makes a big difference. So see, if you have a radiused edge, then your coating thickness is consistent around the entire edge. And on big projects, when you're coating beams, especially at height, and access is expensive, but you've got to put up scaffolding, or you've got to use a hydraulic lifter to go up. And to do the repairs, often they can cost 3 times as much to repair these. So we said to the guys, rather get it right first time, and you won't have any problems, and throwing away thousands and thousands of rupees because you've got to go back and redo. So it's these simple things, but they're critical, you know. And as long as you respect that sequence, you'll never have a problem. You'll never, ever. Now, this is showing you here. This is a different steel supplier, and you can see it's already pre-radiused when you buy it. So there's a channel iron and there's a T section, and they're both, so they're ready to be blast cleaned and put Zinga on, and they're perfect. They don't need any. apart from the cut ends where you just give it a quick dressing off. Takes 30 seconds and away you go, ready to go. No problem. It's so critical, inspectors even have these, this radius gauge, and they can check it. If it doesn't fit, they'll call you back and say you must take your sanding disc and go over it again to get the radius correct.
See, I want
So-
to interrupt one. See, Ranjit, your company does blasting and painting. So you all must be aware that you have to prepare the surface like this. Others in other regions, when you are selecting an applicator to apply, you all should ask him questions like this, that suppose there is a sharp edge, how are you going to coat it? Suppose, how do you measure the radius? Does he have these instruments? And when he has, once he's talking this language, then you know that he knows about surface preparation and he'll do a good job. Yeah, over to you, Rick.
Sorry, Abe, if you're recording this, you can send all these fellows a copy.
I am sending all of them a copy, definitely.
Perfect. Then if they have any questions to direct to you, please, they can ask any questions at all, and we will help them. And remember, we have some guys who, like in Sweden last week, they said, "Oh, I have a question, but it's a silly question." I said, "There's no such thing as a silly question. Every question is important to somebody." And very often I see one guy asking a question, say, "Sorry, it might sound stupid, but blah, 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 you know." And I watch, and there's at least another 5 guys writing down the answer because they're too shy to ask. So I said, please, there's no such thing as a silly question, ever. If you don't ask, you won't get. So please, nothing's too small, okay? And it could be very important, a small item like that. So please, never be too shy to ask, ever. So these are the points. Thin coatings are always weaker than thick coatings. This also goes for paints as well. They will break down much quicker under UV. And also, as I said earlier, thin coatings can allow vapor transmission. So actually, your overnight condensation sitting on the paint can actually penetrate at a microscopic level. It can go through the paint onto the steel, believe it or not. So if you apply it too thin, that actually helps it. And the same as for rainwater. If you have salt, again, as we said earlier, salt ion. So you have electrons flowing through the steel and ions flowing through the water. They're both an electrical charge, but there's different names. So yeah, a thin coating will definitely give you a much shorter service life. Okay, there are sometimes a situation where it's impossible to get in. We have guys that have been called in to refurbish parts of a refinery or a big sugar processing plant, and the beams are very hard to access. Said, okay, do your best on the sharp edge. If you can blast along one side of the edge, and then blast along the other side of the edge, and then stripe coat it with a brush, and build it up. As Abe was saying earlier, you use a brush to stripe coat it and build it up. And then when you put your coating on, you'll see it's consistent again. So these are the 3 steps. You can see that. So stripe coating there, very, very important where you cannot blast an edge. That's showing you the full build-up now. So the blue areas where you've applied by brush. Okay, after you've done all your work, you've got your pre-cleaning. And this is also part of the, I think we cover the pre-cleaning. It's also with welding. If you've done any welding, you will have weld spatter, all those little spots on there. And we say, don't grind them off. Again, use a sanding disc with 36 grit, 40 grit. When you go over it, it cuts off all your weld spatter, leaves it nice and smooth, ready for blasting. And again, pre-cleaning is a vital stage, because no coating will stick to oil or grease. There's no coating in the world will stick to that. And you have many sources. You have steel work that comes from a machine shop. So all the bending and cutting, some of them use that white water-based oil, but it's still oil. Drilling machines as well. So any operations that are using cutting, welding, drilling, whatever, there is going to be oil from the machines. You have oil from the gloves. I've worked in more than 22 countries and I've never seen clean gloves, ever. they're always covered with stuff. You're always handling everything in the shop, in the workshop. So you will have oil on your gloves, always. And the fork truck, when they're lifting heavy steel, the fork truck tines, they also get oil on. Normally not much, but there could be enough. When they go underneath, they're sliding, they're rubbing oil into it as they go underneath to lift the metal. So fork truck tines also can have it. So please, anything. And when we say you can clean it with detergent, even the detergent you use for cleaning dishes, it's the same stuff, more or less. Of course, because it's commercial or industrial, they're triple the price. But we know guys who take detergent from their house for small jobs, put it on with a rag, a bit of water, and soak it, give it a good rub. And then the important thing is to use a hose pipe. Never rub it off with a cloth, because there's stuff on the cloth. You can spread any contamination from the cloth. So when you've cleaned it, you remove by pressure with a hose. So here are the 5 main prescribed methods. So on big projects, where possible, steam cleaning is by far the best. And nowadays from China, they're making these small steam units, very, very good price. And you go in there and just pull the trigger. You stand well back with your goggles, and you just steam it. And the steam, the heat, it melts the oil and grease and makes it flow down. And the pressure of the steam, it pushes it off your metal onto the floor. So when you walk around, I think steam cleaning it, when you stopped, the heat of the steam makes the metal warm, so it dries very, very fast. And that metal is spotless because you haven't touched it with your hands, with gloves, no rags, nothing. It's just spotless. So steam, if it's an option, it's always the best option. And all you do is just clean the floor afterwards because it's all flowing on the floor. Second best choice is detergent washing. Okay. Some detergents are called alkaline detergent washing. So basically, I've had guys make their own up because I've said to them, if it's too expensive, you take a normal detergent and you add some bleach, 10%. That's the alkalinity, okay? And again, strong alkaline will remove oil and grease. It breaks it up and destroys it. So if you put bleach in with detergent, bit of water and then spray it on, or even small areas, you can apply with a brush and give it a good soaking. Leave it for a few minutes to work, and then come back. And again, if you have a hose, even a garden hose with a jet, and wash it from the top down, okay? Again, don't touch it with hands or rags, anything like that, because you can get transfer of contamination from a bad area to a clean area. Always wash off with a brush, with a hose pipe. The third option, which is more expensive, is high pressure water jetting. Those machines are very expensive to rent on a regular basis, but on big projects, they are very fast. Okay. I think in Europe to rent these high pressure machines cost 350, 400 euros a day. But on a big project, time is money, and that is by far the quickest. It's very, very fast. It takes off oil, grease, any salt if it's near the coast. It takes everything off in seconds. Your next choice is solvent cleaning, but again, solvents have to be applied with a rag. Okay, you're not allowed. Most countries do not allow any solvent to be coming out of an atomized nozzle from a spray gun or a jet. It's illegal and it's dangerous. So it has to be applied by a rag, which is not ideal. And the last one, of course, is UHP for marine structures. So, for example, when we do jetties and so on, when they go in to do a survey, and you see the photographs, and they've got about 30, 40 millimeters of barnacles and shellfish. They said, oh, we can get a team of divers in there with air chisels, and they can chisel off all these things and then clean off the surface, make it ready for blasting. I said, when you're working in a tidal zone, you don't have time for that, eh? So you get a UHP machine, 2,700 bars, and you walk along and it blows off everything. Takes off all the mussels, barnacles, it takes off rust, any mill scale, any old paint, the lot is off in 3 seconds. Literally, it's very, very powerful. And the work of 5 men can be done by that machine, not even a quarter of the time. It'd be less than a quarter of the time. That's how fast they are. So for me, there's no option on a marine project, especially if it's tidal. This is just to show you that that's a guy standing there, steam cleaning the bottom of a big, huge machine. And you can see to try and hand wash that with detergent, that's a big job. So again, it's not a clever thing to try and do by hand. It's 150 bars. We say 140 to 150, 160 bars, anywhere there, minimum. And that will push off all the oil and grease once it's been softened back by the steam heat. The detergent, again, you wash down the steelwork with detergent, and that they're available in every country. The detergents they break up oil and grease, and it floats to the surface of the water. So while you're jetting, it's coming away from the steel surface. And again, if you put in some bleach, that actually has 2 advantages, believe it or not. When you put bleach in, it still breaks up all the oil and the mess, takes it off the steel, and then you rinse it off. If there's any residues left behind, it's high pH. And believe it or not, it can leave a micro residue on the surface. So that actually stops anything from rusting for 2 or 3 hours. So there is an advantage to having the bleach in your detergent if you're going to hold up on site. And again, all the oil and that are removed by pressure from the water jetting. That's showing you there how he's doing a rinse off. This is 700 bars. If you're working near the coast or in harbors and so on, this will remove chlorides. So in many countries where they don't have access to chlorid or whole blast, these desalting chemicals, we had a big project in Pakistan at the harbor, and they had a lot of oil and grease. And we said to them, use high pressure water jetting. And they said, there is one available on the shipyard. I said, well, just borrow it and do that. And they said, will it work? I said, it's just jetting. I said, yeah, it's the pressure. Okay. It's the pressure. The energy from the water hitting that steel at 700 bars or above, it actually heats up the metal by about 3 degrees centigrade. And the metal, microscopically, it actually opens up, and the water is forcing out all the salt, all the chlorides. So you won't have any contamination on the steel at 700 bars. So that's how it looks, the special nozzle. And you have to always wear gloves. Although the only dangerous part is the first 100, 120 millimeters. After that, there's no danger from the pressure at all. Solvent cleaning. This is the only one that is done to A standard, SSPC, SP1. And if you guys ever want a copy of this, we're not meant to send it to you electronically, but if you need a copy, we can send you one on the quiet, just so you have a good understanding what's involved. And UHP, that you see there, if you look at the bottom, see all that shellfish, all that crust, you try and break it off by hand or even using an air chisel, which is pretty fast. The UHP would clean that whole area there in half an hour, 45 minutes, believe it or not. It's amazingly fast. These are just your different definitions. This is international, so you know, when someone says they want to use high pressure, then they must understand high pressure water blasting is minimum 340. So a lot of guys think 5,000 PSI is high. We said, no, it's not. That's actually low pressure. Again, pre-cleaning. When guys said to me, okay, we're going to wash this down and we'll do a solvent rub and all this, I said, no. I said, all the paint companies told you this, all of them. And I said, it's crazy. If you have a rusted surface like that, how can you have rust on that metal if it's got oil and grease on it? Because that acts as a barrier. So water cannot get to the metal. It cannot rust. It can't dissolve and make rust because the oil and grease. Rust is also slightly porous. So anything you put on there is going to be absorbed in and make it even worse. So I said, if you're going to do your blasting, rather go straight in now on that and just blast clean that. It'll come away and then make a little bit of rust dust, but underneath that metal will be shiny and clean. There'll be no staining. So rather go straight in blasting. Don't do pre-cleaning on rust. It's very, very bad. And what I was saying earlier with ExxonMobil in Malaysia, they have this rust. And they said we have many areas that are going to be blast cleaned in 5 years' time. That's our shutdown. It's planned, it's budgeted. So every few years we have these major shutdowns for 2 weeks. He says, but the rust cannot advance and get more pitting or whatever. And that's why we designed the frontline maintenance on that sort of surface. So that surface you see is an orangey sort of color. So that would be removed with a wire brush, de-dusted with a clean paint brush, so it's all nice and clean. And then you put aerosols. So you put maybe 3 or 4 passes, maybe more. Let it dry, come back, put another 3 or 4 passes, and you build it up to 100, 120. And we said to them, you want 5 years. Okay, that might give you 7, even 8 over rust, believe it or not. And as I said earlier, the pull-off values they got from our system was unbelievable. So this is how they start. And we said to them, don't confuse this with any other repair systems where people are using angle grinders and sanding discs. With frontline maintenance, you're working with rust only, eh? So that you don't muck around with rust converters, rust removal, nothing. You just remove the top layer of rust, work with the bottom layer. And so we're working with the rust, not against it, okay? And that saves them. And just so you know, after the first year, after they had the successful demonstration and the pull-off testing and the adhesion, they did a bit more research. In the first year, they ordered 60,000 aerosols. And again, in the second and third year, they ordered 60,000 aerosols each year. Now they order so much. In the last 18 months, we've had to build a second factory in Malaysia, which will then service India and the other countries, Australia, Thailand, Indonesia, will be serviced from that new factory because the demand for Zinga spray was so high. So we've sold millions already for this sort of work. It's amazing. This is just your levels of salt on the surface, chloride levels. So this is blast cleaning. So the blast cleaning is a very, very old system. I've had quizzes. I've given fun quizzes to some distributors around the world. And one question was, when did they start blast cleaning? They said, after the war, they started to blast clean and put it onto bridges and blah, blah, blah. And everybody was wrong. One guy was close. He said, I believe it started before the war in 1932. I said, actually, it started before the First World War in 1919. The first blasting was done in 1891, believe it or not. So it's been around for over 120 years. And because it's such a perfect system for steel preparation, in 120 years, they have not found anything better than that. Okay, at the moment now, we're doing a lot of trials with laser cleaning, but that'll take years to be on the market commercially. But we're already in with the laser guys, so we're ahead of the game. But blast cleaning is going to be around for many, many years to come. Another thing with the Zinga, on a blast clean surface, you got your peaks and valleys, and the Zinga is going inside the valleys. This is why when you have an impact on a bridge from a truck, and the guy said, wow, the zinc didn't come off, because you have a profile with the zinc. If you have an impact, it's pushing the zinc inside the profile. It's not coming across the top and ripping it off. And even if they have a shear factor, we saw this in Singapore, a truck hit the crash barriers, and they had been done with Zinga that had already been recoated a few years beforehand on the highway. And all it did, it sheared off the top layer of Zinga. Okay, so you have your profile full of Zinga, and above it, we had the zinc layer that was taken back to the top of the blast. But there was still zinc inside the metal, So when they came along with rollers, they recoated the Zinga on top of the existing one, and it was redone at a very low cost with 4 or 5 guys and rollers, and then it did a whole kilometer in a couple of days. So it was repaired quick, and the city council couldn't believe how fast it was, and at such a low price. So now they're saying all the other barriers that are coming up for renewal, all the old galvanized ones, they're going to be done with Zinga, because they can see the maintenance costs are so low. And also the throw. So we mentioned here in the second point here about the throw of the zinc layer. So Zinga has a throw of 15 millimeters. I don't have a blank panel here. Okay, but if you had a steel panel and you blast the whole panel and then you coat one half with Zinga, and this half you leave uncoated. If you then put it outside in the rain or by the sea for a couple of weeks, the blasted part will start to corrode and turn orange as normal and go rusty, but it'll corrode up to 15 millimeters from where the zinc stops. And it won't corrode. That part there will still stay silver. It won't corrode. That's the throw of the zinc. So this electron flow we discussed earlier from the zinc layer, it's flowing 15 millimeters from where the zinc stops. So it's actually protecting outside of the coated area by 15 millimeters. So it'll corrode up to that point, and the rest, it won't corrode. That's the throw of Zinga. It's a very similar concept to when you bolt anodes onto a ship. That anode has got a throw for about 2 meters on either side. So you see anodes bolted along a ship, or on the harbor wall, they have the sheet piling. They have a big long anode every 2 or 3 meters. The throw is protecting. It's exactly the same as Zinga in water and in rain. It's throwing all the time. So you have different types of blasting. Obviously, the oldest is grit blasting, which is with a dry grit. So this is normal abrasive blasting. You can prepare the steel at 14 to 16 square meters an hour. Inside steel sheds where they recycle the abrasives. Then we recommend to use chilled iron. We've had some companies saying, "Oh, chilled iron, if we use normal black slag, it's 100 euros a ton, for example, and chilled iron is 450 euros a ton." I said, okay, according to the new laws, all blasting slag that's been used is now classified as toxic. So you buy 50 tons a month of slag. When it's used, you then have to bring in the truck to take it away. You're paying for 50 tons to be taken and dumped in the landfill every month. So there's your costs already going up, okay? When you buy the chilled iron, you can reuse it and reuse it and reuse it. And as I say here, 40, 50 cycles. And each time it hits something, bits break off. But those bits are sharp, so they still have cutting power. So you can recycle and recycle. And if you have a measuring gauge, you simply measure your depth, which you do anyway, before you apply the Zinga. And when you see your profiles are getting shallower, you simply buy a couple of bags and you add it into your pot, okay? All abrasives come in 25 kilogram bags. You just top up your pot and you measure, you'll see the profiles, they're going very deep again. It's as simple as that. And you keep on going. And because it's chilled iron, it breaks down. Eventually it becomes a dust and it gets sucked out your vent, your air vent, and blown into the atmosphere, lands on the ground and becomes ferrous oxide. So it's completing the circle of life. So it's not detrimental to the environment. It's completely natural, completely normal. So you avoid all these costs of trucks coming every week, taking away all your stuff. The guys who argued, when we showed them this, they actually phoned us after 1 year and they said that we've saved them 4,500 euros in the first year by using chilled iron. Obviously on site you can't, because you'd lose it. You can't recycle it. There you have to use copper slag or garnet or whatever. So this is the abrasive blasting that's been around over 120 years. vapor blasting. This is only a few years old now, and what happened more than 25 years ago, they had slurry blasting, which is a similar concept to vapor blasting. So when you are slurry blasting, your blast pot was full of your abrasive, and instead of having compressed air like normal blasting, you had compressed water. So when you pulled the trigger, the water came out with the grit, and there was no dust. But in that system, it was using 20 liters of water a minute, which is a lot of water. And in many countries, they don't have such a supply of water. Then this very clever man introduced vapor blasting. Vapor blasting is a similar concept. You still have your blast pot with water inside and your abrasive, but on this system, you only require about 15% of the water needed in the old systems. And more importantly, you only require maximum 35% of the abrasives. And we had a job recently where a guy was going to do a bridge, and we said to him, you should vapor blast this job. He said, we have the normal blasting pots. I said, how much are you going to use on this bridge? He said, about 150 tons of abrasive. And I said, you got the contract? He said, yes, we were awarded it last week. I said, okay. Instead of using your blast pots, just rent 2 or 3 vapor blasters, okay? And see how much money you save. He said, why? I said, because you'll only require 30% of the abrasive. You will blast the same square area to the same depth, but you're going to save 70% of the cost. They're going to pay you for dry blasting rates, so you're going to be saving, what, 10, 15,000 euros? Excuse me. So he tried it, and he couldn't believe it. So when the truck came to site, instead of having to bring 150 tons, it only brought, I think, 45 tons. So vapor blasting is a massive, massive development in the last 7-8 years. Incredible. That's how it looks. If
And
you can
I
see
want
this
to
blasting.
highlight one more thing that we use
Yeah.
in our factory, copper slag blasting, and the amount of dust it creates, it becomes impossible to be around that area. It is very polluting. So these vapor blasting techniques are far more cleaner, provided you have access to water.
Exactly. Yeah. And also, in most of the warm countries, the blasters wear these big, heavy leather suits and the heavy bulletproof glass shields. You can see this fellow. He's just wearing a pair of safety goggles and no heavy suit, nothing. So you can see the safety aspect. And of course, when it's making it's called vapor blasting because it does make a little bit of mist, like from a kettle. So it looks like vapor, but it settles very quick.
And one
of
more
course,
thing,
on hot days.
many sites,
Yeah.
dealers, whenever they say you cannot do blasting, you can use these techniques because they are far less polluting and they give the similar kind of profile which is needed for applying the coating.
Exactly. That's a good point, Abe. In many cities around the world, they've banned blasting, but they don't ban vapor blast. So when you're vapor blasting, the abrasive doesn't go all over for like 100 square meters. It actually drops. If you could see, I don't have photographs, but if you could see this guy's feet, all the abrasive is bouncing off the side of that ship and is landing at his feet. So clean up. They just come with a big yard brush and a shovel, and they can sweep it all and put it in a trailer in half an hour. Finish. They're not there half the day trying to pick up all the dust and that. And there's also no dust drifting into neighboring yards or projects or whatever, car parks. There's no dust drift. It all just drops straight down. So housekeeping on site is very, very simple. It's a quick cleanup. 20 minutes, the guys are off site. It's very, very fast. This is vapor blasting at height, just to give you an idea. So these are guys doing towers.
Bijoy, this
not-
is for you. Bijoy, you are always finding some challenge in doing towers, right? So this is a good method of doing.
Yeah. What about the flash testing after the vapor blasting?
Sorry, Bijoy?
Once we cleaning with the vapor blasting, moisture content will be there, no? Because of the moisture, flash test will come.
This guy you can see on the right hand side here, you can see he's got a one-handed blasting jet. Okay, normal blasting on the ground, you have a dead man's handle, so one holds and one pushes the trigger. This one was imported from California for this job, and we did some trials in the UK. And because international law says when you're working on towers, you must retain 3 points of contact. So both feet,
Rick, his question is that when I do a vapor blast, the surface is wet, and it is always recommended that on a dry surface you apply the coating. So it doesn't this sort of create a problem.
what we found in most countries, that the surface dries off in 3 or 4 minutes. So it's never an
very,
issue.
very less water, more of vapor, which is doing it. So that's why the drying time is faster, right?
Yeah, exactly. And just so you know, these guys are working in this tower. So they're working on the left-hand side. So that phase has been shut down. So they can do 2 or 3 towers in a week on the one side, and then they come back, and then that side is powered up and the other side is closed down. So because if that was live, they wouldn't be blasting, because you can get a flashover with mist. So they're working on a dead tower. There's no power there. And this is the difference. On the left-hand side, you can see the blasting. And when you're blasting dry, you won't see with your eye, but under a magnification, very strong magnification, you can see dust residues in the bottom of your blast profiles, right at the very bottom. When you vapor blast, it's a different physics involved. So as you're striking the surface with the abrasive, the water is coming around the abrasive at the same time, and it's continually scouring the surface. So what they say in the industry is that dry blasting, you're cutting from the top down to the bottom. Vapor blasting, you're cleaning from the bottom up to the top. It's a much cleaner blast. And as I said, the water dries very quick, and it looks nice and clean and silver, and it's really clean. This one is bristle blasting, which is taken off. We first tested this about 10 years ago when it was still fairly new. But since then, they've developed new machines. And of course, recently, they've now launched the ones that are battery operated. So you can climb towers onto bridges. And if you're doing small spot repairs with Zinga, you can bristle blast, dust it off with a paintbrush, a clean paintbrush, dust it off clean, and then put on the Zinga with a brush. It's as simple as that. So bristle blasting does have fantastic capabilities, but we emphasize it's only for small areas, okay? So if you have a critical area that's corroding, like next to a valve or a gas flange or something like that, you can go in and bristle blast that area and then put on the Zinga. You can be in and out in half an hour. It's very fast. If there's some guys trying to do a big section of a tank, and we said, man, you can't do that. You know, your work rate is 1 square meter an hour. So to do a small repair with that, and the guy said, well,
it is very expensive. And it is
Yeah.
very expensive.
Yeah, the belts. You have to treat it after 1 square meter. So if you're doing 10 square meters, that's 10 belts, and that's about 300 euros. So yeah, it's rather get a guy in with a blaster and give it a quick sweep blast. Even it's still cheaper than bristle blasting, but it is for small areas and treating welds and critical areas. Very fast and fantastic. See, this is the guy doing a weld on the side of a turbine tower. So, and this is just to show you. And if you look at the blast profile on the right-hand side, it's fairly similar to that of a normal blast cleaning. Very similar. Okay, automatic blasting. Okay, this is where you have these machines. You're putting through big beams. We did railway tracks that are 18 meters long, and the blasting rate was 1.2 meters a minute. So to blast 2 rail tracks was taking on average about 20 minutes to do it. But it's much faster and far more accurate than having to hand blast. I know in some countries they still hand blast, but it's a long process. This is much quicker and much neater. Vacuum blasting again, 1 square meter an hour, like Bristol blasting. But you can see it's this is for inside food factories, pharmaceutical places where they need to have the area galvanized with Zinga because coatings keep failing. And we said, okay, but you go in with a vacuum blast, there's no mess, no dust, get a good profile. And again, they apply Zinga with a brush or first coat brush, second coat roller, and it comes as smooth as a sprayed finish from a spray gun. It looks really neat. So we can offer solutions for anything in any project, literally. So we don't only give answers. When they have a problem, we will give a solution to anything like that. Sweet blasting. Again, if you're using Zinga on hot dip galvanizing, it's 2 things. We do lots of repairs on galvanizing worldwide. So sweet blasting is a set technique. Okay, you hold your nozzle at 45 degrees. Okay, not 70 degrees like a normal blasting. It's 45 degrees. And instead of blasting at 6 bars, you blast at 3 bars at that shallow angle. So when you're sweeping, it's breaking up the hot dip galv and removing any loose flaky bits. And it's removing little bits of zinc off the surface, but it's making it rough, but it's not removing the thickness of the hot dip galv. You want to retain that. And this is actually a standard in Australia and New Zealand now, this method. So when you're blasting, so it's not only for repairing hot dip galv. We've had some guys phone us and say, we had these galvanized beams, big beams, they weigh 5 tons each. They were hot dip galvanized, and we check on site and they're sub-spec. Hot dip galvanizing is normally around 83, 85 microns, and these beams were 60, 62. So same thing, sweet blast, and then spray on the Zinga, and it builds up. So on hot dip galvanizing, sweet blasting is used for repairs and for increasing the film thickness of the galvanizing. And again, sweet blasting is very fast, okay? Normal blasting, vapor blasting or dry blasting, 14 to 16 square meters an hour. Sweet blasting can be 45 square meters an hour. So it's very fast. There's all your...
Rick, I have a question, Rick.
Yeah.
In India, many of the hot dip galvanists, they over coated with aluminum paints for a periodic maintenance. Yeah, aluminum paints.
What, to have the nice finish?
Yeah. If we want to do the Zinga application, what is the procedure for that? Is it required to remove the aluminum coating from the galvanized surface?
But what some guys do is, if they want to look like galvanizing, then they apply Zingaloo instead of Zinga. So
No.
if they want to build up galvanizing on a large area, we recommend they use Zingaloo from the tin, not aerosol. So you put it on with a gun and you can build up a heavy layer very fast, very fast. And when it dries, it looks, if you stand back, it often looks very, very similar to hot dip galvanizing finish.
Okay, how to repair the existing? Imagine existing. These are the existing poles, light poles, and other kind of things, such as they have hot dip galvanized around 10 years back, and every 3 years their routine maintenance, and they will do the aluminum paint on the top. If they want to give a 10-year warranty.
I very much doubt anybody would warranty that, aluminium paint.
Okay.
No,
Okay.
if the lighting poles are weathered and the galvanizing looks rough, even if they clean it with a wire brush and then apply the Zinga Lu and it'll stick in there, we could probably warranty that. I don't know. I'll speak to Bruno, but that should be 5 to 10 years warranty on that. Because for Zinga Lu, we have ISO 12944-C5 and C5 very high. And where we put Zinga 120 microns, Zinga Lu, you put it 110 and we have the same durability results. So yeah, on those lighting poles, Zinga Lu would be ideal.
Okay. Thank you.
So the blast profiles, they are critical, and we'll show you why now. Okay, blast profiles are needed for all paints. All industrial coatings need blast profiles. Some of the big paint majors, one or two of them, they have these surface tolerant coatings. But when you put it over smooth or messy surfaces, they don't last very long. They might last 5 or 6 years. They won't last 15 or 20 like normal epoxies. So blast profiles are always critical, and I'll show you why. So the blast profiles, you can't see this because it's a little stylus machine, but when they're checking things in a laboratory, they're checking the abrasive effect on steel, you should have 45 to 60 ppc. So when you measure your little blast peaks, you get peaks and valleys. So there should be minimum 45, maximum 60 peaks per centimeter, okay, linear. And that makes sure that the opening is nice. If you had 80 peaks per centimeter, instead of being that, it would be closed like that, the paint wouldn't get down to the bottom. So this is ideal. This is why they specify this. And this is an example of a perfect blast. That's a 2.5 cleanliness. So you are allowed a little bit of staining and so on. But for Zinga, the cleanliness is always important as usual, but the depth is the critical factor here. Because even if it's slightly a bit grainy looking, if you've got the depth, the zinc's going to get in there and grip, and it gets harder and harder every week for the first year. So if you coated that with Zinga and came back after a week and measured it, it would be around about 6.5 megapascal to pull the paint off, the zinc off. If you went back after 3-4 months and did another test, it'll be a minimum, absolute minimum of 9 megapascal. If you go back after 10-11 months, it'll be minimum 11 megapascal. So as the zinc is reacting with the carbon dioxide and the atmospheric moisture, condensation, it's actually getting stronger and stronger. And so when you try to pull it, it gets tougher and tougher onto the metal. And the blast profile is the main anchor. So it's going inside, right inside that profile and giving you your grip. And that's why if you have a blow from the side, like on crash barriers and bridge supports, if it's hit, it can shear off some of the zinc. If you've got 15 tons of lorry, you won't stop that from damaging the zinc layer, but it'll rub it across the top, but inside you still have Zinga. So if you go the next day or so, the next week, and put on with a brush, it'll adhere to the existing zinc and it'll rebuild again. So that's a very key factor. So this is how it looks. So now you can see what I'm speaking about with all the peaks. So that's 45 to 60 per centimeter, and that's a perfect blast. And just remember, when you're measuring DFT, if you're using an electronic gauge, you're always measuring from the blast peaks. Many guys used to think that you measure from the valleys at the bottom. We said, no, because that's inside the metal. You know, you don't see that. What you're measuring is above the surface of the metal. That's your dry film thickness. And that's what happens if you have, say, 70 to 90 peaks a centimeter. They're so narrow, the coating goes halfway down and it starts drying and it stops. It won't flow right down to the very bottom. This is why the peaks are so important. But the blast profile does that for you. Automatically, it controls the peaks. So you won't have that issue at all. And it says here, okay, like for MIG welds, when you're blasting MIG welds, you must hold your blast nozzle a bit closer, because MIG, those welds are full of manganese, so they're extremely hard. So you have to blast it a bit more slowly, or hold your blast nozzle a bit closer. So this is just to achieve the correct blast profiles. But you can read about this. There's your chilled iron, which to me is #1 in the world. Is copper slag, which is used all over the world, in every single country, copper slag. Thousands of tons a week, many thousands of tons a week. Garnet, okay, the biggest mines are in India and in Australia. Because the supplies are running slow, there's not big fights, because worldwide, all the jewelers, you use the garnet for making rings and necklaces. They say that we're a curse on their they say we're a curse on their business, because we shatter it against metal and it makes dust. And that they make beautiful ornaments and things, jewelry using garnet. The trouble is, garnet is harder than slag. Okay, slag is 6.5 mo. Garnet is over 7 mo. And to give you an idea, diamond is 10, okay, which is the hardest in the world. So garnet is still in big demand. A lot of people still use it, but in Europe, it's very expensive now. It's more than double, 3 times the price of slag. But some guys swear by it, and they won't change. So this is to give you an idea. This is a 3D image from a computer. It had a machine with a little stylus, and that needle traced all the peaks and valleys in the blast. And if you look along the outside edges, you can see how deep it goes. The nice sharp edges right deep inside. This is a big no-no, as Abe was showing you on his quiz. This is why you never ever use shot blasting, okay? Because that's what happens. It's rounded off. You have no lateral support. So if you have a shear, if something hit that surface, it's going to rip off all the zinc, because there's nothing to anchor it deep inside the metal. It's just like a golf ball almost, very, very smooth. And there's a 3D image from a computer. There's no deep valleys. If you look around the outside edges, they're all round and scalloped. There's no deep V's. So that's very, very bad. These are just your cleanliness standards that we work to. Again, you can go through these at your leisure. When Abe sends you a copy, and please, if you have any queries on these, let us know. This is another thing you might find interesting. It's not always important, but it's always good to know for background. All steel is graded. So this one is grade A. Okay, it's got a few marks on it, but it's been lying in a factory. So there's bits of cement dust, but that bluey gray color, that's actually brand new steel. Okay, but it's been lying in someone's factory for a couple of months. And that's how it looks after it's been blast cleaned. So that's a rust grade A. So if a specification said you must blast the steel to SA 2.5A, then you know you're dealing with brand new steel. If the steel is older, okay, this is explaining your conditions A, B, C, and D. And rust A is new. After a few weeks, it could be a rust grade B or C. And after several months, normally at the coast, it becomes rust grade D. So it's very badly rusted. So this is a rust grade B. You can see it's got some pitting on the surface because it's been lying around a while. But after blast cleaning, it looks okay. That's perfect for Zinga. Absolutely perfect. Rust grade C, that's been lying around a lot longer. And you can see that on the left-hand side, you can see that the corrosion is much deeper. But once again, after blast cleaning, and this is using copper slag, still looks perfect for Zinga. Absolutely perfect. And this is the worst situation. You can see here, the rusting is very, very bad, very deep. And even after blasting, you can see it's very lumpy looking. But even over a grade D of steel, if you put Zinga on that, it's still going to last you 25 to 35 years near the coast. It'll still give you that durability. So there's no changes at all. And this is the definition, okay, according to the standard. It should be completely free from oil, grease, dirt, mill scale, rust, all paint debris, and any foreign matter. So even if it's badly pitted, it still conforms to this. So there's not a problem at all. This is the depth to length conversion. Again, this is one of the critical areas of a blast profile, but many people didn't realize. So for example, you have a corrugated tin roof. That's what I have in my office. And you can't beat African style. It's still very waterproof for many, many years. So if you take a sheet of corrugated iron and it measures, sorry, that's actually the wrong thing there. That's actually 1 meter. I beg your pardon. I don't know why it's got 1.6. When you get a 1 meter wide sheet of corrugated iron, if you pull it straight out, it becomes 1.6 meters, okay, in width. When you take a blast profile, again, 1 meter long, and you blast clean with slag to 60 microns, if you could pull that straight, it actually comes out to 2.6 meters. So, for example, if you have a square panel of steel, 1 meter by 1 meter, and you blast clean it, you're not blast cleaning. When you coat it, you are not coating 1 square meter of steel. You're actually coating 7.1 square meters. So the zinc is actually sticking to 7 square meters. And this is why when you try to pull it off, it's physically impossible. All the best testing we've seen done with powerful machines to pull the zinc, they call it cohesive splitting, because the zinc splits in the middle. The zinc has never come away from the steel that I've ever seen. It always cracks in the middle, because that's the only weak point that they can find with the pulling off. And that's why the blast profile is so critical. It gives you so much strength. It's incredible. We've challenged people in Germany and some countries. And I said, what do you think? What do you think of that coating? He said, it looks good. I said, here's a hammer. Hit it. Yeah, it'll chip. I said, no, it won't. It won't chip. Hit it. And he's tapping away. We said, yeah, and we take it and we hit it. And we hit it so hard, we smash it. And we said, do you have a bigger hammer? Have you got a 5 kilogram hammer? Did you have a 10 kilogram sledgehammer? We will beat the steel so badly, the whole paddle will be buckled, but the zinc will still be on. It won't come off. That is the strength of the adhesion. And we've done the hammer test a few times. It makes people laugh, but my God, the guy's eyes, when they see all that beating, it won't come off. And this is just to show you some of the things that you work with in the laboratories. So blast cleaning is in fact an advanced science. It really is. So we just show the basics to comply with the standards, because that's all really you need to know. So that's pre-cleaning and blast cleaning. Okay, now we have dedusting. Again, this is part of the 5-point sequence. Okay. After blast cleaning, dedusting must be carried out all the time. So if you're working outside, the guys normally have a little air duster for the air line from the spray gun. Just plug it in and they just pull the trigger and they just blow it. It blows all the dust away. If you're working inside a big blasting shop and painting shop, that's not a good idea, because when you're blowing all the dust off, it goes up into the air. It's got nowhere to go. Then it falls back down again after a few minutes, back onto your surface you've just cleaned. So we're saying if you work in a shop, there's no fans running and there's no air movement, then rather get a small vacuum cleaner. You can get these small cheap ones and just suck the surface and suck all the dust off. And especially, if you have a weld cluster where you have maybe 2 or 4 beams welded and a central one welded together, get in there and suck all the dust out, because cluster welds are really busy areas. And sometimes blasting won't get all the areas, all the dust out. Not always. So outside, yeah, blow it off very, very fast, quick. Takes a few seconds, very, very fast. Indoors, just take a bit more care. That's what we're saying. If you've vapor blasted a surface, after it's dried, then do your dust test, okay? And we'll show you. It's a very simple test. That's basically what you require. Okay, if you buy the kit, as always, you get ripped off. They'll charge you about 200 euros for a dust testing kit, which is absolute nonsense. So all you need is some clear tape. If you can get the wider one, which is normally available in most countries, you get one that's 50 millimeters wide. Okay, and you basically tear it off, a strip maybe 150 millimeter, put it onto your surface, and then rub it in with your hand. Okay, or the palm of your hand, rub it in, and then peel it off, and then you can see the dust, what's on there. So that's what's showing you here. So when you remove the tape from the paper, you put it onto the excuse me, you put it onto a backing card. So for example, if you're blasting with copper slag, your backing card would be white, because when you put your tape onto the card and then check it, you have a good contrast in color. If you're using things like aluminum oxide and those sort of abrasives, they're very, very light. So then you would use a black backing card to see what it is. And basically that's it. That is your card. So when you put your tape on there, you hold your card up against this chart and put it side by side, and you can see visually is a grade 1, a grade 2, 3, 4, or 5. We always say grade 2 or below. I don't know why it's worded like that. They could have just said it's grade 1 or grade 2. That's it. But we accept grade 2 or below. If you have grade 3 or grade 4 dusting with any coating, not only Zinga, if you spray it on, it's potentially going to stick more to the dust than to the metal. So you don't have a strong adhesion. So this is why you want to remove the dust. So you're sticking straight onto the steel itself. Okay, there's nothing in between. And yeah, so I'll just show you there. There's your kit that you buy in a fancy little case. So you can buy your own sticky tape. I don't know what it would cost in India, but it'd probably be the equivalent of about, I don't know, €1.50 or something like that. You can have a torch if you want with a magnifying glass built in. A lot of guys don't bother. And then strips of black cardboard and white cardboard. You can buy that from any shop and just cut it into strips, say 50 millimeters wide, and have some black and some white on site. So you can make up your kit, and you can conform to the ISO 8502-3. And to do that, it'll probably cost you, say, maximum 10 euros, and not buying a kit for 200 in a fancy box. And it's completely acceptable to any inspector. Okay, that's not an issue. And finally, we also want to discuss flash rusting before we discuss the Zinga itself. Flash rusting is when you blast clean a surface and the humidity is quite high. Okay, normally the critical humidity is about 60% humidity. And also if you're working near the coast, so if you're working in a harbor or in a coastal region, say within 5, 6, 7 kilometers of the sea, the atmosphere is normally very moist, so it'll flash rust. And we've had some guys phone and say, oh, we've left it. We had to go off to get some diesel for the compressor. We came back after 3 hours and all the metal's gone orange. It's flash rusted, so it's kaput. So we have to reblast. I said, no. I said, if it's 3 hours long, if you wipe it with a rag, okay, and it comes off as a faint dust, that's a light grade of flash rust. You can apply Zinga over a light grade of flash rust, believe it or not. And they said, oh, we were told that rusting is bad. I said, no, light flash rust, okay? Flash rusting happens on the peaks. So you have your valleys, but you have your peaks. They are the highest part of the metal exposed to the atmosphere. So the peaks have flash rust on each peak. When you stand back a few meters, it looks like all the metal is orange, okay? But if you go up close with a torch and put it on the surface and angle the torch towards you slightly, you'll see a metallic sheen coming off. So the valleys are not rusted, only the peaks. So if you still apply Zinga as normal, it'll go inside. It's still having direct contact inside every valley. It's got direct contact with the metal. You'll still have your electrons flowing from the zinc into the metal. Your steel is fully galvanized and fully protected. And the peaks, they're already covered because, as I showed you, the DFT is measured from the peaks up. So they are completely enveloped inside the zinc layer. And because that orange rusting is normally nanometers, nanometers, which is a millionth of a meter. And at worst, it could be 2 or 3 microns, which is still nothing. So when you apply the Zinga and cover that, you will still get the same durability. If you're applying a C5 very high system, you will still get 25 to 35 years durability on flash rust. So don't panic. Some people say it's the end of the world. It's not. If you get flash rusting, then you leave another day or two. Yeah, then it gets medium grade. Now you've got a water jet, or at worst, you have to reblast it. So we say, when you blast clean metal, coat it the same day. Always coat it. The zinc should be on and even touch dried 1 hour before the sun sets. Because when the sun starts setting, you'll feel the temperatures dropping and the humidity rising. Okay. I saw this in Africa over many, many years, and it's the same all over the world. As the sun's going to set, everything changes. Get the zinc on. And again, we've told guys in big projects last week as well, I said, only blast what you can coat the same day. We had one company, they blasted 150 square meters. And by 4:30, 5 o'clock, they only coated 70 square meters, 80 square meters. So of course, the next day it was flash rusted. But luckily, there had been very little overnight condensation. It was still wet, but again, it was a light grade. It only rusted the peaks. Excuse me. So I said to them, "You're very lucky. If that had been a medium grade, you'd have to water jet or reblast that whole area again." So the message: any area you blast, coat it. Even if you're struggling because of delays or the machine broke down, coat as much as you can before sunset. Then the next day you can deal with the problem. But if you've coated the majority, then you're much better off, much better off. So this is your dry abrasive blast. It concerns your humidities, as I said. Also with vapor blasters, but by the time it's dried, if you're in a marine atmosphere, by the time it dries, it could start flash rusting. So vapor blast, and within an hour, you get the zinc on within an hour, and then you'll have no problem at all. And I just wanted to show you, these are your different humidities. But I wanted to show you this. This is the official photographs, which are not very clear. Light, medium, and heavy flash rust. That's clear. And believe it or not, this system is used by the US Navy, excuse me, and by some other navies doing ships and that, because as you know, anything in the sea is more critical for coating. So you see the light, and the official method is you rub from right to left, and then left to right, and then right to left again. That's the that's the official test method. So if you have moderate or heavy flash rust, it's either water jetting or reblasting. But light flash rust, you can apply Zinga. Interestingly, most paint companies do not allow you to apply paint because they'll fail. But because Zinga is a live coating, generating electrons into the steel, it's not a problem at all. So light flash rust is never an issue. Okay, I just told you all that. Okay, this is just if you have access to chloride or the various chemicals. Many countries around the world can't access, even in Europe, many countries can't access these chemicals. So this is why it's always better to get the zinc on before sunset. We can't even get them in the UK, believe it or not. So this is the end of this webinar. So if you have any questions, or you want to have a cup of tea for a couple of minutes, and then I'll give you the next one, which will show you how to prepare the Zinga. It won't take long. I'll just close this down for now. Okay, where are we here?
Hello. Yeah, you can
Yeah,
have a tea,
hello?
sir. You need to continue again, otherwise, sir.
Yes, we're going to
Hello.
continue.
Yeah, you can
Hello,
have
can
a
you hear
tea,
me?
sir. Take a short break. You can have a tea, sir.
Okay. Want a short break? Okay.
Yeah, thank you.
5 minutes. Okay.
Yes, sir.
I'll just load the next one in. Is it gone? Where's it gone now? I've lost my screen thing now. Damn it.
So you need to take a break for 5 minutes.
No, I'm just trying to load the next one up so I can continue. I thought if you wanted a 5 minute break.
Yes, yes, yes. Or you
Okay.
need to continue
Yes.
right now. Is there any this thing too long, or it's like
Yeah.
too short? Now how
Okay.
long it will take to continue right now, sir?
If I can get this thing to load, I'm struggling a bit. We can continue immediately.
Okay, you can be yes. You can just go continue, so then. Are
Okay,
everyone
thank
ready?
you, Vina. I've just got to get this thing to load.
Vijay, sir, you need to speak to something or what?
Is
Hello?
there somebody who knows I can get this up again?
You can continue, sir, if you need then.
I can't find this this thing at the bottom. Has disappeared. How to reload this?
See voice access, like the on place mic to activate voice access. You just press the mic, sir, to activate voice plus access. Can you hear me?
I can hear you, Vina. Yeah.
So you can continue whatever your training is going on then.
Yeah, I'm trying to load this this next part here, but it won't load because the bottom of the screen it hasn't got the little screens where you click.
Can you share the screen, sir? Just click on right side of your screen and share the screen.
Sharing. Okay.
Got it?
I think it says it's uploading the presentation.
Okay.
Just a moment. It said. It says we're unable to share right now.
Okay. Now what to do now? Shall we continue on Monday, sir? Is it okay with you? Or should
No, look, if you are running out of time, we can continue on Monday.
okay. So that's fine.
Normally,
Let me know the timing, sir. The same timing on Monday, sir?
If you want, yeah, we can do that.
Right now, are you like the screen is working right now of yours?
My screen's working, but I can't show it to you. So normally at the bottom of the screen's got a little TV screen. I click on that, and then it opens immediately. But that's not on my screen at the bottom.
So click on right side of your screen and just share it out.
This is a nuisance. There's nothing at the bottom to show me anything now.
Have you got it?
It's not. It won't open this. Hang on. There's a new share. Is that it here? You can see that?
No, we can't see.
You can see now?
No, sir. The voice access wake up on press and mic button to activate voice access.
You can see that now?
No, sir.
Still nothing?
No, sir. So is there any kind of this thing on any kind of this is problem is creating while sharing the screen, sir?
Yeah, it's. You still can't see that?
No, this is a webinar, Zinga Metal, the webinar number 2, no? The same thing.
That's it.
Yeah, that's it, Meena.
So you can see?
Yeah,
No,
we
sir.
can see.
You can see it, sir.
Yeah, I can see the page number 2.
Okay, then that's fine. Then you can just carry on with this presentation, sir.
Content.
You can see that. Okay, that's fine.
Yeah, thank you, Veena.
Yeah.
Sorry, guys.
No,
All this
no,
modern
Fine,
technology.
fine.
This modern technology is it's
It's
got a
fine,
lot
sir,
of my
it's
old
fine.
brain.
It's fine, sir.
Thank you. Okay, so this is just a few topics we'll cover quickly for you. Okay, how to mix it, dilution, your wet film versus dry film thickness, stripe coating, full coating. So it'll be very quite quick. First we do mixing and dilution. Okay, and all zinc coatings are very heavy in the liquid state. So when you pick up the drum, you feel it's very, very heavy. The zinc particles in Zinga are much smaller than the zinc particles you find in paint. This is why in very, very small gaps, the Zinga will go right inside there. It can gain access. And that's why when you're coating over rust, it goes inside the rust because the particles are so small. But because there's more particles, and for example, a 1 gallon tin, 5 liters, there's more particles in there. So it's 2.7 times the weight of paint. That's how much zinc is inside there. And that's why we have such a good voltage of electrons flowing from the zinc. So the first thing we do with any container, and when you remove the lid from Zinga container, you don't have that rim, which is a real pain in the bum, you know. The Zinga, when you take off the lid, the tin is smooth and then it curves out. So you put in a stick to scrape the sides. So the zinc might be sticking a bit to the sides. So you just scrape it around like that first. Okay. And then you can mix it with a drilling machine, with a propeller, and you can power mix it very, very quick. So normally for brushing or spraying, we say you dilute by 5 7%. So, for example, if you have a 5 kilo tin, you'd put in 1 coffee cup. That's about 5%. A coffee cup of solvent. Very easy to mix inside then. And then you power mix for a few minutes, and then just pour it through a strainer, and then you can spray it. It'll come out smooth as glass. We have in some countries, we have people who redo old classic cars, and when they dilute Zinga 15-20% and spray onto the car body after blasting, it's as smooth as glass, literally as smooth as glass. So the straining in that is a very good idea. On big industrial projects, if you're using the 10 kilogram or the 25 kilogram, when you're scraping, also scrape the bottom of the drum, because some people leave up 5-10% of the zinc in the bottom of the drum. So scrape the sides first, then pull it across and scrape the bottom, then power mix, and it lifts everything up. And then when you put the solvent in and power mix, it'll incorporate it so you don't waste any of the zinc. This is what we send out in some countries. So you remove the lid, you scrap it, you power mix, dilute by 5%, mix it again, and then pour it into a clean drum, and then you spray. We say pour it into a clean drum. So if you're working you're spraying a ship or a bridge or something big, it's nice to pour it into a clean drum, okay, through a strainer. Then you know that everything in that drum is spotless. There's no dust or anything in it. So that's the only reason we say that. Some guys don't bother, but we recommend it on big jobs, so there's no blockages and you can spray all day long with no problems. So this is the normal mixer. This fellow is holding a double-handed mixer. So on big projects, it's very fast. If you're mixing a lot of drums every day, that's much faster. But everybody has their preference. Some guys just use a drilling machine with a mixing paddle. They all do the same job, and not a problem. This is your wet film thickness. So we have some people who don't have the electronic gauge to measure the dry film after it's been applied. So, and this many people around the world don't have those. They're either too expensive, or they get broken, or they're just not available. So if you know how thick to apply it wet, you know how thick it's going to be dried. And that's all you need. That's all you need to do. It's as simple as that. Okay. So on the sheets, if you ask us for a specification for a certain job, we'll compile it and send it to you. And we always show the wet and dry film thicknesses for any project, okay? So if you don't have an electronic gauge to measure the dry thickness, you work with the same figures on the wet thickness, which is right next to it on the sheet. So everybody is covered. You don't have to worry about that. So as we say here, to calculate the exact thickness, wet, okay, you calculate that so you get the correct dry film thickness. It saves you wasting and doing over applications or under applications. And it keeps it pretty accurate. And then you will get your durability that you promised to the customer. So the volume solids, okay. If you look at your data sheet, Zinga is 58% volume solid. So if you apply it wet at 100 microns, it's going to dry at 58. Because that's how much solid zinc is inside that. The rest is binder and some solvent. So what we're saying here is, if it's 50% and you apply wet at 100, it'll dry at 50. But because zinc is 58 and you apply it at 100, it'll dry at 58. That's how simple it is. Okay. And so this is how it works. So we're showing you here, coatings are made up of pigment, binder, and solvent. That's all they have. Okay. That's the basics. Some have anti-foaming agents, leveling agents, so on. But with Zinga, it's got none of that. It's just the zinc and the binder and a bit of solvent. So we're showing you here on the left That's the wet film. As the solvent and the volatiles evaporate, it starts to go down and down and down. And when it's fully dried, so in India, like Africa or Australia, it'll be fully dried in half an hour, and then you can walk on it. So in half an hour, all the solvent has come off, and you're left with a dry film. So on the left, if that wet film was 100 microns, the dried film on the right-hand side would be 58 microns. It's as simple as that to calculate. So here we have a little formula for you. So there's your formula. To calculate the wet film thickness, you take the dry film thickness that you want to achieve, multiply by 100, and then you divide it by the volume solids. So if for example, we say, okay, on all these big sheets, they're going to be welded. So you only want 60 microns of Zinga. So you take 60 microns times 100 is equals 6,000, and then divide it by your by 58, which is your volume solids content in Zinga. And you'll see this on your data sheet. Zinga's got 58% solid inside that wet film. And there it tells you 103 microns. And I'm sure if Abe hasn't given you the wet film gauges, we will send some over to him by aeroplane so he can give them to you. And you take your wet film readings. So if you apply it and wet, and you measure it wet, and it's showing you maybe 95, you can apply one light coat very quick. Okay, but if you measure it and it's showing 96, well, just leave it. Okay, that's close enough. It doesn't have to be exactly 103. So this is a good guide for you to work with. And this is this formula, I've been using it for 49 years and nothing's changed. So please don't worry about that. It's always the same. It works for paints as well. Okay, so it's always the same. It's a very simple concept. If you get stuck, we'll explain it in more depth if you want, but that's basically it. So you look at your specification. If you're doing it near the sea and it's 120 microns is a standard system for coastal, okay, if you calculate it, it'll come out roughly 210 microns. It's as simple as that. And that will dry at 120. So it's very easy to calculate. So this is to show you here, as I was saying earlier, that's how you get your, if you want 100 microns of thickness, same thing. You take the 100, you multiply it by 100, it's 10,000, and you divide it by the 58% volume solid, 172. So if you get 165 or you get 178 wet, leave it. That's fine. It'll dry so close to your required dry film thickness. So don't muck around putting extra coats, whatever. If it's close enough, just leave it. It's fine. You still get your durability. Okay. Sometimes when you add your solids, you have corrected volume solids, but this complicates matters. So I won't cover that part because it really doesn't apply normally. Just stick with this. This is the basic one. So yeah, apply by 100 and divide by 58. It's as simple as that.
That's right.
Okay, if you reread this on your recording, if you have anything you don't understand on this, please let us know, and we'll write it out in more depth if you want. It's not a problem. We want you guys to be happy, and you have to be in your head. You must be satisfied that you know all these things, and then you can give it to your customer. So we're here for you. Requirements for good coating. Good correct mixing with a power wash, with a with the power mixer propeller. Okay, some people stir it with a stick. For small amounts you can, but when you get bigger and bigger, always use the mixing blade you get from the hardware shop. And then dilution. Okay, some guys don't dilute, and then it can be a little bit thick. And if it dries fast on a certain day, you might have a slight unevenness. If the customer wants it dead smooth, then he might moan at you. I mean, you're still fully protected for 35 years, but so dilution can be important for brushing, rolling, and spraying. You know, use 5 to 7%. We recommend good gun control. So when we say control, your gun control, the painter is the guy who's controlling the wet film thickness. So in fact, the painter is the guy doing quality control, nobody else. The painter cannot blame anybody and say, oh, you know, we've got big runs and sags and it's a big mess. You say, no, it's your fault because you didn't control the gun. So if you set up the gun and do a couple of passes and it's nice and smooth and it's drying, that's fine. But if you do 1 or 2 passes and it starts to run, it's far too heavy, or you've added too much solvent. There's no other excuse. So if they measure their 5-7%, as I said, with a 10 kilogram tin, it's a coffee mug. Better advertise for Zinga there. So a coffee mug of solvent and 10 kilograms. That's your 5%, 7%. And yeah, good gun control. So when the guy's spraying and it's a nice even finish all over, it'll dry, it'll look fantastic. So after blast cleaning, the first thing we always do is stripe coating, okay? So all the liquids have surface tension. So when they dry, they pull as they're drying, they're always pulling at the surface and they shrink a bit. That's why we said on sharp corners, they pull away. Okay, so stripe coating, for many decades in the coating industry, it was underrated and it was neglected. And in America, many bridges, the paint company said, okay, this will last you 30 years before you have to reblast and repaint. And sometimes after only 18 years, they were seeing rust appearing. And the experts went to inspect and said, the rust is appearing in sharp edges and over welds. The rest of the bridge was fine. And that's when they introduced stripe coating as an official part of coatings. And like in America, that country is crazy, you know, they want to sue everybody for everything. So if your painting breaks down 10 years earlier, they want to sue you and then you have to repaint the whole bridge. And, and nowadays in America, for example, in Minneapolis, they had a triple arch bridge that the blast cleaned, and to blast it and paint it, it cost $12 million.
Great. Great, sir.
And because of modern regulations for atmospheric cleanliness and all that, when you blast a bridge now, you got to scaffold and you got to wrap it around the whole bridge with plastic, and the plastic has to be sealed. So when the guys are blasting, all the dust gets sucked in a big pipe under the bridge and into a truck or into a big boat with a huge metal container to hold all the dust. And we said to the guys, if you don't stripe coat and this breaks down in say 15, 20 years, instead of 30, 40 years, to reblast this will not cost you 15 million. By then it's going to cost you 25 million. So get it right first time, or it's going to cost you a very lot of money. And stripe coating is all the areas where it breaks down. And of course, with the paint, if it breaks down in one area, the atmospheric moisture gets underneath every night and it starts creeping and it goes underneath the paint and the rusting, and the paint starts lifting off and blistering. And it isn't like Zinga where you can have a damage, but because of the throw, it's still protecting the steel everywhere. So even with damaged areas, it will not corrode. It just sits there. But with paint, if it's damaged, but we still apply stripe coating to Zinga as well. So you're getting the decent coverage over every single aspect of any project, whether it's a storage tank, a bridge, transmission towers. Every square millimeter must have the same thickness of zinc. And to do this, it takes stripe coating. This is just to show an example. You can walk into any ship that's maybe 10 years old, and you'll see this on all the access hatches immediately. And I'm talking any ship anywhere in the world, you see these things because they were not stripe coated originally. These edges, even on a pipe support inside an oil refinery, They had edge breakdown there. And of course, that pipe you can see, that pipe had crevice corrosion because you have two metallic surfaces close together. Overnight condensation was sitting on the flat part, and it was going inside that joint, and it was corroding the two surfaces. So if that was blast cleaned, you would stripe coat the edges that have been ringed off there where it's rusting, but you would also stripe coat inside that crevice joint. So you would not see that crevice corrosion taking place at all. And as you know, you've seen it on cars, and in Africa, my God, there's thousands of cars like that, especially in Durban, because of the high temperatures, the high humidity. So nobody is exempt. There's bridges all over the world, always on the edges because they didn't stripe coat it. And unless you show people this, they don't realize the importance. They think it's just another pain in the ass job, you know, to complete the job. But it's a critical part of any coating process is stripe coating. And as Obe said, these are always done with a brush. So you get a nice thing. You can go along it like that. Some guys do it that way. But if you do it vertically, you're actually getting a nice build all the way around on these things. So it is so important. And again, the blast cleaning. This is showing you where you cannot radius because it's a bridge or inside a processing plant, and you cannot get access to blast that edge. So we covered this earlier. You see, if you can blast either side of it, and in some cases you might have to grind with a 36 grit sanding disc, but if you can do either side of that sharp edge, and then put your stripe coat on, you can still stripe coat it, and that area becomes protected when you put on the full coat. So there's the full coat. So that's fully protected. So stripe coating in every aspect. This is a job that I was working on in Togo in North Africa. Okay, up in that month it was 35, 38 degrees, and the humidity was 80, 90%. But I had the team, I helped them, and I said every single plate. This was a railway bridge, and these plates, all the old crisscross channel irons, they were all corroded, many years old, 50 years old, all being replaced. And so on these there was more than 300 of all these. Each of these panels was hundreds. Every single one was stripe coated, and then the next day the guy came with a spray gun and just sprayed on the full coat and covered them. So instead of doing individually, you put them together, and he sprayed like 10 at a time, so it was quite fast. And when you spray them, okay, you can also brush and roll the coating on. As long as it overlaps the stripe coating, then you have an unbroken film of galvanizing over the entire surface. So there's no weak areas at all. There's no thin areas. Everything's thick and solid all the way around. So each one of those panels was fully galvanized. And we said to the bridge owners, this will be there for the next easy 30, 40 years, easy, because of that. I was inside a shed, and I was showing these guys all the drilled holes where the bolts go through to bolt the new bracing on. Every single hole has to be stripe coated inside, okay? Because I say if you don't, and you put the bolt through, your overnight condensation, the water can go inside those holes around where the bolts are, because they're not watertight then, and it can start corroding, and then the Zinga will be throwing to protect it, but it'll start having more zinc depletion faster. So some of those areas might not give you the full 35 years. They might only get 28 years, which some guys think's okay. But for us, we said, no, I'd rather do it perfect and use a brush and coat every single hole. And then you'll see along all the edges and all the cut ends, you'll see they've all been stripe coated as well along the lengths. Then when they sprayed again, we overlapped all of the holes and all the edges. So that's showing you a hole there. It's as simple as that. And then when they're sprayed, everything's coated. So that's your stripe coating. Always be done by brush, unless we state you can use the gun on big beams. Always run parallel to the edge. Crevice joints must be back brushed. So that means you're brushing one way and then pushing against it. That's back brushing. So you're cutting it that way and then back brushing it, pushing it inside the joint and you'll never ever have rust coming out of that joint for years and years. With stripe coating, we say along edges and around holes, try and give it a width of about 20, 30 millimeters, okay? It's not critical, but it's just a good guide. So when you're spraying, you know you're going to overlap those areas. So all holes and edges are very, very well protected. And then, yeah, the full coating, again, your dilution can change how the coating dries, how thick it dries, how thin, how fast, and so on. The painter must apply the wet film thickness as shown in the spec. So again, he knows how thick it will be when it dries. Very heavy layers can produce little blowholes. So while it's still wet, you see little bubbles because you put it on far too heavy. It happens occasionally, but the bubbles eventually will pop and they'll shrink down. So you haven't compromised the durability, okay? You still have the full protection. But if a customer sees it, he might get a fright. So again, this is a poor application because you've applied it too thin.
Yeah, right.
So it's very important. If you spray Zinga like this and didn't cover your blast peaks at the top, when you come back the next day, you're going to have spot rusting on top of the peaks. And in the trade, this is called measles because it looks like when you have measles, you have little red spots everywhere. So that's measling or measles. So in that situation, give it another 2 passes of the gun. That's all. If you're near the sea, you might have to wash it down first. But inland, not a problem. Just give it a couple of passes of the gun or a roller or a brush. Just give it 2 passes and see how it looks. And if it's thick enough, you can leave it. If it's near the coast, you might have to give it 1 or 2 passes, let it dry, give it another 1 or 2 passes. That's it, finished. So either way, you've retained the durability of the system. This is also over dilution. So when you're spraying, instead of saying 5 to 7%, we've seen this occasionally when a guy's put maybe 10, 12% because he didn't measure it properly. And some guys said, oh, we don't have an accurate measuring jug. I said, you know, in Africa, when they have a big drum of Zinga and they haven't got a jug, they use a liter bottle, which used to hold Coca-Cola or something, and they fill that with solvent. That's 1 liter. So now they can calculate how much is 500 cc's according to how much zinc they got in the drum. So there's always a way to do it. You don't have to have laboratory equipment for accuracy. So here it is over diluted. So when they sprayed and it started drying very fast because it was 35 degrees, you can see here it's some areas are deeper than others. So if you measure that with an electronic gauge, your readings are going to be all over the place. And that's also under dilution. So when you're spraying, sometimes each pass on where your passes overlap, you might have little high spots. Yeah, this has been exaggerated. It wouldn't be as bad as that, but it just shows little high spots. It's not serious, but again, some customers want a completely flat surface. They'll be very fussy. So there's a good example. It shows you the blast profile, and it's been filled with Zinga, and it shows the DFT above. So when you're measuring the wet film thickness, your little film gauge is actually sitting on top of the blast peaks, okay? So it's measuring from the top of the blast profile. That's where it should be. Quality control, okay, that's the painter. And again, I'm going to show you these are the gauges, okay? And this is how you check it with a wet film gauge or a paint comb. If you haven't got one, ask Abe for one, or he can give you 2 or 3. If he hasn't got,
we have it in the factory.
You have? Okay, perfect. So this is how they look. Okay, you get an Alcometer, you can get the other ones, but these are like 65, 70 euros for some of these ones you buy from online. They're very expensive, and ours is free. It does the same job. Okay, so on your wet film chrome, the way they're made, your corners are always level. So when you stand it on the surface of the steel, That's how they look. And you'll see each tooth get shorter and shorter as the wet film gets thicker and thicker. So here, that pink is showing you the liquid zinc, okay? It's been pushed in and it's touching the tooth of 50 microns. So therefore, you know that coating is 50 microns wet. So if you do your calculations, you know that's going to dry around about 23, 24 microns dry using that little formula that you saw. So that's how basically how these work. It's very, very basic. And again, this is how these things have been used for many decades, many 50, 60 years. So nothing's changed. Wet film gives you the dry film. Very, very simple concept. So a painter who's in charge of quality control, in his hand, he should also have a spray gun, and the left hand should have a paint comb. Okay, that's it. When I see painters and I said, how thick is that coating? And he says, he's thinking. I said, your left hand is empty. He said, yes. I said, where's your comb? How can you tell me that you know the wet film thickness when you're spraying that big beam? You should be doing 2 passes. If you're starting the job, you do 2 passes, measure, okay, clean it, measure again, measure again. If it looks okay, 2 passes. The entire beam is 2 passes. But if you measure 2 or 3 measurements, it's a bit low. Give it 1 more pass of the gun, measure again. It looks okay. Okay. The entire beam gets 3 passes of the gun. That's how you use a wet film gauge. So whether it's a beam or a big surface of a boat or something, always do your first 2 or 3 passes and measure. Then, if you want, he can put them in his pocket and carry on spraying. But every now and again, he should just take a test reading just to make sure that he's staying on track with the whole beam. So these are used to great extent, okay? And painters should always have one. It should be in his hand. If it's not, it should be in his pocket so he can take it out and do a quick check. So the painter has no excuse. That's his tools of trade, is the spray gun on the comb. So that's it. He has that. He should always do a good job. On the smaller areas, this is the side that we use, because if you're going to be welding steelwork, after it's been coated, it's going to be lying around a shipyard or somewhere for a few weeks, you put on 60 microns, and then you can pick it up anytime. It's fully weldable at 60 microns. So in that case, you would apply here, say between 100 and 125, would be in between those two. So it might just touch the one edge of the 125. So you know it's about 100, 115. It's going to dry at 60 microns. Where you have a guy's putting on a top coat, okay, then you want 80 to 90 microns of Zinga, and then you're putting on a polyurethane or whatever. So then you apply 150, which is the highest point on that side. You would very, very seldom use the other 3 sides of that comb. So after what I've done, on my own one that I carry with me, I take a center punch, and each corner, I just push a dent in. So when I pick it up, I can see immediately the side with the 2 dents. And that's the side. I don't have to look with my eyes. I don't have to look which side to use. I pick it up and I see where the 2 punch marks are, and that's the one I use every time. Just a little tip. So this is the wet film thickness. So your comb is from 25 to 150, and that will cover most of your applications that you do with Zinga. Okay, as I said, 150 is the highest that you normally ever use, and that'll dry at 90 microns. You can apply 260s to get 100 microns. So a lot of people will apply two coatings of 60 to 75 at the coast. Okay, that's normally your normal range. Okay, and they apply, instead of doing 1 heavy layer, they apply 2 at 60 because it dries faster. So each layer will be dry in 50 minutes, but the second coat, that'll be dry also 15-20 minutes, and that job's done. If you apply a big heavy layer at 250 microns, that's going to be wet for a much longer, maybe an hour. an hour and 50 minutes, because the solvent's coming off the top, but the solvent underneath has to come up to the top and go. So the whole drying process is much slower. So that's why a lot of people will put on 2 times 60 or 60 to 75 is the average for the coast anyway. So because the second layer will soften back the first layer and melt together, okay, and that's one of the big charms of Zinga. Whether you apply 2, 3, 4, 5 layers of Zinga, if you X-ray it, there's only one layer on the steel, and that's why we have such a powerful electron flow. So that current's flowing very strongly because it's one layer. It doesn't dry into different layers like epoxies does. So we warn guys, okay, just be careful with the painter. If you apply the first layer and it goes nice and hard in 20 minutes, when you apply the second layer, sometimes it softens back the first layer to melt together. When you put your comb, it goes inside the first layer as well. So you get a false reading. So if it's a big project and you want to have good accuracy, what we say is let the first coat dry at 60, 75 microns, nice and hard. Get a little piece of glass or a little piece of very smooth steel and some masking tape, okay, top and bottom, and tape it onto one part of the surface. When you're spraying, you go over that glass panel with your passes. And when you take measurements, take it on the glass, or if it's steel, take it on that and you'll see. And again, if it's too thin, it needs a third pass, check it again on the glass, then peel it off, just go chup chup with the gun so the damage is gone, and carry on. And same thing, you will still give it another 3 passes. And then you'll have a very accurate second coat. This is just again to show you a wet film thickness. If you want 100 microns wet and it hits 75, which is the green arrow, that's too low. So it might require another pass of the gun. So that's what we're saying when you're checking. If you take your reading 75, clean the gauge, one more pass, check it again. And I'll tell you why you check it. Because
Hey,
some
Rich,
painters,
just wanted to tell you, so we told them till 5 o'clock, so that's like 6 minutes from now. And I'm sure there's lots more to cover. So should we plan today to end it in 6 to 8 minutes?
yes, yeah, sorry,
Yeah.
I forgot about the time. Okay.
Thanks.
But what I'll just quickly say here, when you're checking with this, it varies from company to company, okay? Because some guys will do a pass and their painter has got a very fast hand. So he might do one pass and check it again and it's still too low. Whereas in another company, the painter does one slow pass and he measures, okay, that's perfect. So where you measure 75, some guys might take 2 passes to get 100, break up to 100, and others take 1 pass. That's why you test, you check it. Okay. It's control, and then duplex again. It's just duplex means 2 or double. So basically, you put the Zinga on. If they want some color over the galvanizing, you can also put a thin primer, or you go straight on with the polyurethane. Okay, a 2 component. Put on a very, very light coat. 15, 20 minutes. Give it a second very light coat. The job's done. That's it. Finish. So you can galvanize and put color in a single morning, not a single day, single morning. So what happens with the duplex when you're spraying paint over Zinga? Your first coat is very light. You go off, have a cup of tea, come back after 50 minutes and look. If you look down at it should be completely matte. That means that the zinc has sucked all the coating into its porosities. That's why you do this, because all zincs are porous. All zincs have little porosities. So you put a very light coat, it gets sucked in, it's completely matte. That indicates that it's dry, now ready for the second coat. If you apply the second coat, also nice and light, it'll sit up and dry with a high gloss. You get a perfect finish. When you put the first coat and it's all matte, if there's a couple of shiny bits, give it another 10 minutes. That's all. Then come back, it'll be matte. Then apply your second light coating, because most polyurethanes go on at 60 to 80 microns anyway. So your second light coat, it'll always sit up nice and give you a nice shiny finish, and that's it. The job's done. So that's basically your duplex. That's just showing you the layers and all that. So that's basically it. But you can go over this thing. Triplex is the same thing, but instead of putting your PU, if it's liable to be hit by traffic, bicycles, women with prams, whatever, any impacts, we always advise to put it on a sealer first, like a Zinga loofah or something like that, over the Zinga, thin, just 40 microns, and let that fully cure. And then you come back after 4 or 5 hours and put on the polyurethane on top. And that's a strong system. It'll take a lot of impacts. That's a triplex. So duplex means 2 and triplex means 3. It's as simple as that. So I'll leave it there, you guys. That's I think that's all you need to know for today. If you want another session to show you how to do spraying and all that, we can do that next week if you want. Not a problem.
Yeah,
But
we'll
this
do
is how
that
to
next week.
mix.
We'll do that next week. Any questions anyone has?
Sorry, Abe?
No, I'm saying we'll do the session next week. Does anyone have any questions?
Yes, sir. The question is from
Yeah.
my side. Yeah, actually, what happens? I have a scenario for you. So actually, the thing is that I have visited a projects engineer's office. He has told that he is using only rebars which are made from pure steel and PVC pipes. It doesn't corrodes and he doesn't require Zinga or any coating. So how it is possible, sir?
The only rebars I've seen like that are stainless steel, but normally they're so expensive that most people won't use them.
So it is
Every other rebar is coated.
so it should be coated or because on that he's saying that there is no corrosion should occur in future or that is whatever the life goes on of the structure, corrosion doesn't take place on that bars. Should the pure bars are not affected by corrosion?
Normal rebars will corrode. Always they will corrode. That's for sure. So if they're not corroding, he may have these bars made in China and in America, and they have a thin layer of zinc on them. Okay, so you get 2 types. You have the hot dip galvanized bars, which has got a very heavy zinc layer, so they're very expensive as well. And the other one is called CGR, and CGR rebars are coated at a very high speed, very high
Right.
speed, and the lengths come up to 40, 50 meters, sometimes longer. They go through the zinc bar so quick. The galvanizing doesn't have time to become a full galvanized layer. So it only has an ether layer on top of the rebars. And we've said to guys, Zinga is an ether layer as well. This is why we're halfway through the paperwork to have an ASTM standard for Zinga. It's taken us 18 months and thousands of pages of paper, but we compare to CGR galvanizing like they do in America and China. But normal rebars will corrode. They will corrode. People forget that concrete is inherently is going to crack, because concrete, as you know, is very, very hard. It's got no give. So when you have a bridge or a dam or a sea wall or something, the earth's moving all the time. When the tectonic plates move, the earth moves and it causes cracking. On a bridge, if you have a bridge structure weighing 40,000 tons or something, as it settles into the ground, that also causes cracks. Then in the hot countries, I mean, in Queensland, North Australia, there's 40 degrees. When I was there a few months ago, so you get thermal expansion of the concrete, and that causes cracking. So there's so many different reasons for it cracking, and once it cracks, again, your friend, the overnight condensation, comes down inside the crack, and if it mixes with air, with carbon dioxide, okay, you get carbonation of the concrete, which means that it breaks down, because initially you have a very high pH around the rebars, and that protects it. But once you get carbonation from carbon dioxide dissolved in water,
Yeah.
The carbonation inside there, when it helps Zinga, it actually attacks concrete.
Right.
It breaks down the pH. So if it starts off at pH 12.6, somewhere around there, 13, it starts to lower. And when it gets down to around about pH 11, the protection breaks down. The rebar starts corroding at a high speed.
Yeah, right.
So you cannot have plain rebars. We've done a lot of projects with zinganized rebars, you know. And they said, what's your design life? We said 100, 110 years. No problem.
Yeah, but sir, he's
But-
saying that is no coating is required on the pure steel bars. Is it true?
On what rebars?
Pure steel bars. On pure,
Ordinary,
yeah, on
pure
pure,
rebars.
yeah, pure steel rebars.
All steel rebars are made with a fairly similar formulation. And one of the highest contents in there is manganese. That's why
Yeah.
if you try and bend a rebar, it's very difficult because they are extremely hard.
Akhilesh,
And
you
having
can
manganese,
ignore this customer also, because sometimes some customers are unrealistic. You can ignore the customer and you
Yeah.
can move on to the next.
Oh, fine, sir, fine. And one more thing, sir. In the metallic ropes, there are various companies who are building metallic ropes. In that, if Zinga is applied, that is for a coating, then what effect, what advantages it will create for the ropes?
I can send you photographs of ropes that we've done on big bridges.
Yeah,
When you're blast cleaning, you use a finer abrasive.
yeah.
So you won't do any pitting on the strands, you know.
Yeah.
And normally what they do is they will give it a light blast over the ropes, and then they use mitts. It's painting mitts. So you put your hand inside, you put it into the bucket, and then you walk along the ropes, or you climb up the ropes on the scaffold, and you work it into the twists. And they use painting mitts for that. So yeah, we've done that.
Nice.
So still, if you want photographs for reference, please just send me an email and I will send you photographs of
Oh, fine,
some
sir.
of the stuff we've done on those bridges. Not a problem.
Definitely, sir. Definitely, sir. I will send. I will send, man, sir.
Good. Yeah, we're here to please. Always.
Thanks.
Okay, I'm sorry to overrun. I will wish you guys a nice weekend, and I hope
Yeah,
you
but
found this
it was
informative.
very informative, guys. Let's give Rick a big round of applause.
Thanks,
Thank you
sir.
so much, Rick.
Thank you.
Yeah,
Thank
and
you.
we'll plan another one. I'll share the recording. Please share the presentation with us so that we can forward it to everyone.
Perfect. Okay.
Thanks.
Yeah, whenever you're ready, we'll have, the last one will be shorter. Okay, it'll only be not even 1 hour, so it'll be showing you all the applications and stuff.
Yeah, we'll
How it's
figure it
done.
out and we'll plan it earlier. Yeah.
Okay. Yeah, next week. If you're free
Yeah,
for an
thank
hour,
you.
perfect.
Thank you, Rick.
Thanks.
Okay.
Thank you.
Thank you. It's a
Thanks.
pleasure.
Thank you.
Have a good
Thanks.
weekend.
Same to you, sir. Same to you.
Okay, Abby.
Thank you.
Yeah, thank you, Rick. Thanks a lot. I'm at the station, so that's why it's a little loud.
Thank you.
Okay.
Okay, fine. Thank you. Akhilesh, just ask someone to
Thank you,
exit,
guys.
end the meeting from my PC,
Okay.
please. Thank you.
Oh, sir.
Okay. Thanks again.
Yeah. Oh, thanks. Thank you. Thank you, ma'am. Madam? Reena ma'am.